Ankit. Not important. Good morning. Before we talk about CAM, let's talk about dancing. You know, I said the two best dancers will get a titanium pen. Now, since I was the judge, I had to dance the whole night to see who is dancing the best. Okay, so I've got two candidates who won, but the second candidate, I cannot find her. She's a woman with a white dress. I don't think she's here, so I have to give it to somebody else. Anyway, so the winners are Ankit from SolidCAM India, and Milan from SolidCAM Serbia.
Thank you, sir.
My pleasure. Come here. Yes, sir. You know, I knew these people are skilled. I never knew they were such great dancers. Okay, so my first lecture is I want to prove to you that SolidCAM is on the right way. And who is better than SimData to tell us what's happening in the market? What do we need in CAM? So, according to SimData, there is a growing need for more sophisticated CAM. You could read it in the latest report. Okay, why there is a growing need for more sophisticated CAM? Because manufacturers are striving to produce higher quality goods that could command higher prices and yield better margins. Every manufacturer, that's his target, to make higher quality goods and get better margins. Now, higher margin performance derived from producing higher quality goods and lower labor and lifestyle costs remains the strongest driver today that pushes the adoption of sophisticated CAM software. That's what I'm saying. People need more sophisticated CAM software, and we have to provide it, obviously. So, higher quality and greater margins means manufacturers need them to produce higher quality goods. Now, these highly finished goods generally require sophisticated engineering and machining that in turn require sophisticated CAD/CAM software for design and manufacturing. Another problem today is the scarcity of experienced engineering and machining personnel in most developed economies. And this is driving the need to capture knowledge and automate as much of the machining process as possible using CAM software. This is what we are saying. People want more advanced CAM software, also want automation, because they believe that you need to capture the knowledge of the more experienced machinists and use it for those who are less experienced. Okay, so from the technology side, what is this growing need for more sophisticated CAM? What does it include? First, because of the continued increase in the use of multitasking machine tools. They are becoming more and more because they are much more productive. Also, there is a growing demand for physics-based cutter path strategies. I will explain later what do you mean physics-based cutter path strategies. Also, product design and manufacturing must respond to the trend toward more aesthetic designs. Everything now designed and becoming more aesthetic, more good-looking. Once cars were boxes, now they are so well styled. So we need better design and better manufacturing. Another important driver is there is now creative use of additive manufacturing. And that's why the reason why 2 years ago we decided also to go into this additive area. So the market will place a premium on the products of software solution providers who develop and deliver a superior response to these drivers, and that's what we are trying to do. Okay, first let's talk about complex machine tools. Machine tool complexity and capabilities continue to increase, driving the need for sophisticated CAD/CAM software to create the NC programs required to synchronize their complex capabilities and to optimize their usage. Anybody who uses a Swiss machine understands how important this is. So the introduction, acceptance, and support of multitask CNC machine tools is a dominant trend in the industry. I believe in the next couple of years, every machine shop, if they want to be productive and make money, they need to have more sophisticated and advanced machines because they are more productive, so they could win more jobs compared to others. Performing multiple operations such as milling and turning on a single CNC machine tool, and often in a single setup, typically results, as I said, in increased productivity, faster turnaround, reduced scrap, and improved part quality by avoiding errors in transferring components from one machine to another. I was visiting one of our customers in India who was doing medical parts, and he had many mill and turn machine, regular machine, and he had a Swiss machine. And he told me that once he got this Swiss machine, before he had to do a medical part, he had to move it to 6 different setups in different machines, and now he could finish the part with one Swiss machine. And since the Swiss machine works automatically with the bar feeder 24/7, it becomes a money-generating machine for him. It's amazing what these Swiss machines can do today if you know how to use them for the right type of part. Not every part you can do it on a Swiss machine. Usually smaller parts, but complex like medical parts, also electronic parts, you can do them on Swiss machines. Okay. While more capable, these machine tools are becoming increasingly complex to program and use. So you need specialized software to effectively use these multitask machines. The software defines the tool movement, simulates the operation, simulation is very important, and post-processes the output. Simulating movement is extremely important for an operator to visualize the machining sequences, avoid collisions, and optimize the operations. I think anybody not working with CAM software, just trying to finger CAM on the Swiss controller, he doesn't see any simulation. To test his program is really a very difficult process if he doesn't have simulation. CAM software must provide individual control of each turret synchronization, and produce accurate cycle time calculations. Sync and wait marks must be added to obtain the desired concurrent operation. Obviously, these all sync and wait marks are generated automatically using our operation sequence manager. By the way, they are not talking about SolidCAM, but they are talking in general. But as you see, as I mentioned everything, this is what SolidCAM is today. To program the multi-spindle, multi-tool capabilities of a multitask machine, it is common for the cutter parts to be programmed in the CAM system independently. They are then synchronized automatically by the CAM system, manually by the programmer, or combination of both. Here I want to explain something. Today, somebody who has even a simple CAM system like MasterCAM can generate a toolpath for each of the different operations, I mean the different targets operations, and then he could go get the code for all the different channels, and then on the machine try to do this synchronizing right on the controller. This is not the right way, because he doesn't have simulation, because he generated the toolpath for each channel separately, and then he is doing the synchronization between them right with G-code on the CNC controller. This is not the right way. He has no simulation, and it's a lot of work. while in SolidCAM, this is done by our operation sequence manager. Okay, when executed on the shop floor, the machining begins with the sync codes orchestrating the program flow for each execution channel. ANSI programmers can verify the ANSI programs and their sync codes before using them on the shop floor. It's very important, this simulation. That's the advantage of having a CAM system rather than doing it on the controller. If balancing the execution of the individual channels is necessary, it may be required to edit the sync codes. This also can be done by somebody who's an advanced user. So the growing use of multitask machine will continue to drive demand in CAM functionality to support their ever-growing levels of flexibility and complexity. Okay, so you are convinced SolidCAM can do that, whatever they are saying here? Okay, next. People want physics-based cutter path strategies. What's meant by that? They want the tool motion to be dictated by physics-based analysis. I think Ken Merritt can explain it the best, but I will try just to say it in general. Okay, these physics-based strategies are designed to produce highly effective and efficient toolpath, significantly reducing machining cycle time, that's a big advantage of iMachining, extending tool life, and improving part quality. Most of these physics-based strategies excel when machining hard materials. Isn't that iMachining? Titanium, when you cut harder material, we save even more. I think they were talking about SolidCAM, but they said in general, this seems that. Okay, most traditional cutter path motion strategies are based on the strict geometric shape of the area to be machined. You know, the regular pocket, what was done, take the geometry and do offsets. This is what they mean, that traditional strategies are based on strict geometric shape, plus one or more other geometric properties like step over, for example. Physics-based cutter path motion strategies are based on the way a cutting tool progresses through the material. I think Doron Osaplansky, our CTO who wrote iMachining, can explain to you better what it means when you progress through the material, how you create the tool path. Okay, the step-by-step definition of tool motion considers the area from which metal is to be removed and how the material being cut changes throughout the various machining stages. The resultant motion evolves by looking ahead to see what is coming up and modify feed, step over, and cutting motion in response to the ever-changing material conditions during part machining. That's iMachining changes the feed all the time. Every point of the toolpath can have different type of feed. The software solution relies on physics-based assessments, such as ensuring constant mechanical lateral force on the tool. That's what I said always. iMachining ensures constant force on the cutting tool and spindle, or managing the volume of material encountered and removed with each movement. Another criterion that may be employed to determine tool motion speed and feed is to assure the heat generated in the primary shear zone, the contact area between the moving, rotating tool and the part, is mostly carried away in the chip. This is iMachining. All the heat is carried away through those chips that come out with iMachining, minimizing the amount of heat conducted into the workpiece. So when you touch the tool after you cut with iMachining, it's not hot, right? Really, they are just saying iMachining. So these criteria usually result in tool paths that maximize tool in the cut time, no air cutting, minimize wasted motion, air cutting, reduce jumping around in pockets, you know, iMachining, there's no jumping around, and smoother running of the machine. Typically, they possess continuous tangent motion. That's iMachining, tangents all the time. A more consistent tool load rather than sharp interrupted movements. Okay, so, you know, they say this is the trend of the future. We already have it in SolidCAM iMachining. Next, as I said, because products are becoming more and more nicer, you need more aesthetic product design. So you need then with these complex shapes in an aesthetic design, these shapes need for CAD/CAM software that can model complex shapes and create sophisticated, efficient NC programs. Use of analytics to create more optimal part geometry is also producing non-standard shapes, requiring more sophisticated CAM programming and machine tools. Here comes additive. Additive manufacturing plays an important role because it's possible to generative design. Today there's many generative design programs that generate all these shapes, where you tell it, I want to have these forces, this is the area, and they produce a shape for you. There are many programs like this. But these shapes usually, it's very difficult to CNC machine them. You have to 3D print them and make them finish with CNC machining. So the generative design techniques create shapes that could not be manufactured using conventional subtractive machining. Or it will be too costly to make them only with subtractive. So the improvement in additive manufacturing technique is having a growing impact on the CAM market. 3D printing offers an increase in the complexity of product designs, as I said, which increases demand for more sophisticated subtractive CAM. Through generative design techniques, as I said, there are programs that do that, we create shapes that could not be made using conventional subtractive machining or are too costly to make. I mentioned this already. 3D printing and subtractive CAM are often used in a complementary fashion, with 3D printed components forming a base that requires subsequent CAM operations that can be used to create threads, for example, remove support material, break movable parts free from the surrounding matrix, or create a required surface finish. This we have seen it a lot. Demand will increase for CAM systems that can program hybrid machines that combine additive and subtractive in the same machine. And this is, for example, today, there is a company in Spain called Melchior. They create a laser head with a controller for it, and it could be combined with any CNC machine. So I've seen it with Haas. Also, I've seen it also combined with other Spanish CNC machines. In this combination, you could 3D print and then do CNC machining for finish. Or less usually the opposite. First, do CNC machining and then do 3D printing for some things that protrude from the part. But mostly it's used to first do 3D printing and then CNC machining. For example, when I was in IMTS, I met somebody who is supplying this equipment to Navy ships. Because in the Navy ship, usually they need spare parts, and they don't carry all the spare parts of a complete Navy ship. So what they usually do, they use a Haas with a Melchior head, and they first 3D print the spare part shape, and then they do CNC finish. Why they first 3D print? Because usually the Navy ship doesn't carry too much stock material. So the wire used for the laser head is enough. They have wire, and with this wire, they could generate any shape with 3D printing and then do CNC machining. So SolidCAM 2025 will be the first system that could drive such a combination. Let's see here some example. Usually in hybrid machining, we have different types of operations, like area laser-aided operation, multi-layer laser-aided operation, tool laser-aided operation. These are different types of laser printing. Here we see a complete simulation of a tube spine machine simulation. Okay, Jack, let's see the simulation. This is working inside SolidCAM 2025. So the part was first CNC machine, and now we are adding this tube by laser printing. Okay, you get the idea. Let's move to the next slide. So this is the result after you finish the 3D printing of the cube spine. This is the result. Alex Myasnikov is the manager of this, product manager for this project. If you want to get more information about it, you could talk to him. We'll be releasing it in SolidCAM 2025. Thank you.
Use this one. It's good.
Good morning, everybody. Good morning. Can people hear me? Hi, everybody. Wow, yesterday was a blast. We had so much fun. It was so nice to see everybody dancing and having a great time. And now for the fourth question. Okay. What's the SolidCAM toolpath for complex and configurable deep drilling operations? 1, eye machining. 2, eye drilling. 3, drilling wizard. 4, multi-depth drilling. Shall I repeat? Okay. So, what's the SolidCAM toolpath for complex and configurable deep drilling operations? 1, eye machining. 2, eye drilling. C, drilling wizard. 4, multi-depth drilling. Please answer by WhatsApp only. Thanks. Good luck.
Good morning, everybody. How are you guys feeling? How was the party? Check. It's not working. Okay, now it's working. But we skipped something. So, amazing party, right? Oh, maybe something happened. Guys, what I saw yesterday was the true SolidCAM spirit. You had no idea what's going to happen, and we all had a great party. And, you know, I had to do something. I put in 2 videos of yesterday where we can see what happened. I hope that you all remember. Wachten für dein Boris Zell. Danke. But this, I was thinking this could be a regular evening. Quiet, nothing is going to happen, but it is what it is, right?
5 minutes later.
So we make awesome software and we make awesome parties. Let's enjoy it a little more. And you know, when I was cutting the video in the morning, I woke up early, I thought to myself, okay, you need to do something. And then I realized, look at all of us, 430 people from all around the world here in this audience and yesterday at the party. It's hard to get not emotional talking about it, thinking about it. And you know, having this spirit, serving the industry together, for me it makes a difference, and it is an honor to work for this company. Because, you know, there is work, there is fun, and if you combine it, it's called, you name it, SolidCAM. All right, so let's get back to business. We are still in Germany. So I asked this question on day 1 because I do think it's true. Is finding the right partners a business hack? Yes, definitely it is. And I can prove it to you that it works after the intro is done. So we were on the AMB, right? And this exhibition is 2 weeks ago. And we were walking through the halls, and Emil already explained that we had a lot of partnerships. For example, this guy's, Hebele, you know all the robo drill machines? Now they created the robo grill, which is a barbecue. Okay, let's continue. We partnered with Vonk. You can see those magnetic things we put on the machines. We had it on 18 machines on the AMB. That means if you walk through the halls of the AMB, no way to not see SolidCAM, and this is what we need to do. We need to be omnipresent with our partners. Again, at STAR, we had our own booth at STAR. Nachwuchsstiftung Maschinenbau. Bechtle was also there. Let's continue. We can do this forever. We had a magnetic thing there. And of all those machines, SolidCAM parts were running. So we programmed it. People see it, and they know it works. Let's continue. Zorn. What was that? Axon. We had our booth at DMG, right? Which is pretty amazing. Again, on a YCM machine. Oh, this is going forever. Another partner, tool manufacturer. We had a molding part here. So it's awesome. We also did a cooperation with the Lademanufaktur, and I have this part here. This is what we actually machined on the AMB, and this is a real part that is built for an engine. It's a turbocharger housing, and together with these guys, we created this, and this is in a tuning car. That means this will go all over the world with our logo on it, which is pretty amazing. Yeah. I had to put engine sounds in it. We gave this part to the executive officer of DMG, and he was pretty amazed that we machined this on a CTX 450. Awesome machine, awesome cooperation. They are really happy. We are really happy. This is what it's all about. Again, the picture you saw already. I want to repeat it, and I know, be patient. This is just important to understand. Every one of you connect to partners. That's it. Nothing more to say after those 2 days of talking about partners. I made an interview with the sales president of Citizen Machinery Europe. I do think it's amazing. I will repeat one sentence after the interview. Enjoy.
Hi and welcome to the AMB 2024 here in beautiful Stuttgart. Today I'm in front of the Citizen booth, and I would like to show all of you what kind of good cooperation we have with Citizen. Come on. Adlin, do you have a second?
Yes, sorry.
No problem.
Thank you.
Hi, Adlin.
Michael, hi,
Hi, how are you doing?
You are very fine, thank you very much.
Yeah. Awesome exhibition, right?
Yes. Oh,
So-
I feel tired. You?
Yeah, definitely. A bit tired, but anyway,
yeah,
we will do it.
Yes, we like
So,
it like this. Yeah.
Adlin,
Yes.
we are so happy to be here at the Citizen booth.
Welcome.
We started this cooperation about 5 years ago,
Yes.
and since then I think we did an amazing job helping our customers, helping your customers to get there faster.
Yeah, thank
Can
you.
you
for that.
just tell the audience who you are?
Yes, of course. For the camera, my name is Adnan Trabelsi. I am working at Citizen since 21 years. I am a sales director. My job every day, taking care about our customer and our partners, dealers. Yes, and I am happy for this interview, Michael.
Yeah, definitely, anytime. So, you told me once that you see more and more people requesting CAD/CAM solutions from you because parts are getting more complex, machines are getting more complex. Is it still the case?
Indeed, this is the case.
Okay.
We have now more and more complex machine. If
Okay.
you remember 5 years ago, when we introduced M machine,
Yes.
M16,
Exactly.
D25, we make interviews
Yes,
together.
exactly, yes.
That was the beginning with the B axis. Now we have a complex machine like L20, ATC, automatic tool changer,
Exactly.
5 axis
The one we have in
interpolation.
our machine shop, yeah.
Exactly. And indeed, in this exhibition, I met customers
Okay.
having your software
Awesome.
and making complex parts. So
Okay.
without this cooperation, our customer has really a problem.
Okay.
And that's why it's important for Citizen to be up to date and to have this cooperation to help our customer. Yeah.
You know, we saw this trend of machines getting more complex pretty early. We started to do really deep development in order to support all those machines. Today we are there. We can support all of your machines here at the booth. And I think it would be very awesome if we can just stay in front of a machine and explain to people what we do and what we can do. So,
Definitely. If you don't mind, we can walk to a machine which I must show
Not
you
at all.
because this is a machine dedicated for your software.
Okay.
And it's an innovation from Citizen.
all right, shall we?
Let's go.
All right.
Okay, good.
What kind of machines do you think CAD/CAM is really needed for?
Very easy. All machines almost. But of course, there is like M machine is educated for the CAD/CAM, ABX with 3 turrets, 3 Y-axis. But the most important machine for your software, for the CAD/CAM, for our customer is with B-axis. Because the B-axis, you know, our newest machine has a 5-axis interpolation.
Yes, of course.
And the customer is looking not only for complex parts, is looking for super finish milling
Yes, of
surface.
course, yes.
And how he should program this 1 million points. So
Yeah,
he
true.
needs a software for that.
And we do meanwhile have customers who are doing pure milling parts, working from a bar, because of course it's way cheaper to just have a bar feeder. They're making hundreds of thousands of parts, pure milling parts. That means we can help the machines that are out there to be utilized more, because hey, this machine can do way more things than just making a diameter, right?
Sometimes there is workpiece, you can not recognize it's coming from a turning machine.
Yes, exactly.
It's a
This is what
poor
I said,
milling
yeah.
machine. But the cycle time and the productivity and let's say the price for producing this part is
Exactly.
totally different in
Yeah.
a turning machine than in a milling machine.
Yeah, definitely.
Let me show you the machine.
Yeah, of course.
with
Let's
the
see if we
B5.
can make our way through.
Yes,
So Adnan, this is the machine you said CAD/CAM is something that is really needed for, right?
exactly.
So let me start the machine.
You have the machine in the showroom, I think you can manage.
Yeah, we know it quite well.
So, okay, Michael, this is the same machine like we have in your showroom.
Exactly, yeah.
L20 ATC with a tool changer carousel means a B-axis swinging, having carousel with 12 stations.
Yes.
So, the difference is here we modify this ATC system with a high frequency spindle,
Okay.
60,000 RPM
Wow.
with 12 stations. This we can use for, let's say, complex parts with the fine mechanic.
Okay.
Special medical sector
Yes.
is requesting this. Or, for example, using sister station. When you have very, very small tool, I'm discussing about the milling tool with the diameter
Yes.
0.2, for example, and the tool life is limited. With the carousel, you can increase productivity.
Yeah, definitely.
The machine has 5-axis interpolation. The parts are complex. Without your help, I think our customer cannot make this super finish surface.
Yeah.
And maybe if the camera can have a look inside to see also this B-axis, Michael. No? Maybe
Yeah, of course.
Yeah. So, and you can see here the combination between software and machine.
Exactly.
Our customer are enjoying it, hopefully, because more and more we have common customers.
Yeah, definitely, yeah.
I hope you are happy with the machine in your showroom.
Definitely, yes, we are. And you know, we see more and more customers who are machining milling parts on a Swiss type machines. That means using SolidCAM helps them getting small parts done that are usually not really turning parts. And I think this shows that the market is also adapting to the needs. We need to get there faster, right? Pricing is always an issue for our customers.
Exactly. And also this with the SolidCAM programming offline, machine is producing, you prepare the next part.
Yeah.
This is a good combination. Thank you for the cooperation, Michael.
Thank you that we are allowed to be here. We are very happy.
Always welcome behind the business. It's nice to work with you and your team.
Oh, yeah, it is.
Yeah, and let's see for the next year.
Of course.
We improve machines.
Yes.
You deliver your software.
We will.
Yeah.
Let's
Okay.
do it.
Thank you, Michael.
Thank you, Adlan.
Always welcome.
So let me repeat one sentence. Without this cooperation, our customers are having problems. And this is why machine tool manufacturers are cooperating with us, because they cannot do it by themselves, as we can do it by ourselves, so we need to just combine. So what are the best partners? Everybody who is speaking CNC. It doesn't matter if it's a machine tool manufacturer, tool manufacturer, cooling liquid manufacturer, it doesn't matter. Use what you have in your country, and Greg Payton is going to talk about the global partnerships today, and he will also explain why it is so important to have these partnerships that usually starting in Germany, in Japan, or wherever, and make their global connection, because it's exactly what we do here, right? We build the network that will help at the end our customers. And there is one more very important partner, and this is SolidCAM Additive. On the AMB, we saw so many people walking up to our booth, and they were having a look to our additive show parts that we showed, because they see SolidCAM is not only CAM anymore. SolidShop, Additive, we are the solid platform for manufacturing, and our customers understand that. They trust us and use the SolidCAM Additive connection and use the team. Jörg Vollmann-Schipper is going to talk about it after my presentation. He is the business director of Additive. Talk to him. This can help us as SolidCAM to get more leads. because at the end, your machine deserves it.
So, good morning, everybody. I hope the evening yesterday was not too heavy for you, and you can also follow then a little bit my explanations in additive manufacturing. Additive manufacturing is something what you probably know, that we established everything in 2022. And we in Germany, with the SolidCAM Additive GmbH, are more or less the only separate company inside of SolidCAM that is just focused on additive manufacturing. Additive manufacturing is not something new, I would say. A lot of you probably are familiar with plastic printers. Some of you have maybe some of these printers at home. We are more or less focused then on industrial printers. But before I want to invite you to the journey, I will ask you two questions. Do you think that additive manufacturing will replace the CNC machine? Maybe that is the reason why also Emil established or founded the additive manufacturing division. And the second question is, what is the reason for SolidCAM to invest into an additive manufacturing market? At the end of my presentation, I hope you can answer these questions by yourself. So, let's go a little bit deeper in the future of manufacturing. What do we currently have? A lot of machine shops have a perfect solution with SolidCAM CAM software, but that is just one thing. And then the second, what we see in the future is also that there's a combination of this CNCing plus additive manufacturing. We have on our booth on the table, we have a sample there. It is a copper part with internal spiral channels, but at the end you also have to machine it where the plug is in, there must be some threads in. So it's always a combination, I would say. You can use the additive manufacturing to bring some advantages in the parts, but at the end, that is our focus, that you have to machine it. So for us, it is more or less a combination, what we say. It is not a competition between these two worlds, additive and machining. Yeah, we see us as a kind of integrator for these technologies. What kind of printers do we have? Emil invested a lot of in this new technology. So you see here our different places, locations where we are. We have in all of these places the possibility to benchmark some parts. And to be honest, we get a lot of requests from our customers, and we are in the perfect situation that we can really tell our customers, would it make sense to go in the combination of additive manufacturing or stay just with machining processes? Yeah, if there are no, from financial side, if there are not any advantages from production side, then we advise our customers to stay with the existing CNCing. What kind of printers do we have in our portfolio to follow or to guide then our customers here with, in this process? At the end, you see the end-use part. That's always important. The second one is also, we always ask our customers, what kind of volumes do you want to produce? Then we can decide, makes this printer sense or makes another printer sense. You will see near the entrance, you will see a separate printer or different printers. But at the end, if there's a question of a customer, I just want to print prototypes, I want to print small volumes, then therefore we have also then a printer. At the beginning, we normally start with functional prototype. That is something what you can do with your plastic printer, whether you use our printer here or whether a customer has his own printers. That is not so important at that stage. But at the end, we have here, you see that printer outside. We have here a new brand. It's called Anisoprint. It's a printer where you can work with endless fibers and different types of plastic materials. The advantage here is the layer height of these printers. An FDM printer is similar to that one what we have with the Desktop Metal Studio System. Desktop Metal Studio System is a printer. The printer is running outside that where you can print green parts similar to an FDM printer, and at the end you go in a furnace. Later on, and that is an important issue for us, it's always the question of the machining. So we print something, and then we go on the CNCing center, and then the customer can have the final end-use part. Another thing is, and that was also some result of the AMB, that we had this studio system with us, the printer was working, but some of these visitors were not so much interested in using printing metal parts, but most of them, if you are then from the machining area, then they make their own jigs and fixtures and grippers. And therefore, you can also use the same printer, the same Anisoprint. You have there more or less the quality of an aluminum. You will see later on a few examples in the presentation where you can print then these kind of jigs and fixtures. If a customer is interested in mid-volumes, then we can also cover it. We have our E-Tech printer. It is a plastic printer also for the functional parts, lower layer heights, and at the end, if the design is frozen, then we can go into the Desktop Metal Shop System. Desktop Metal Shop System is a printer where you can print really bigger volumes. And later on, as before, we go in a CNCing machine, and then the customer have their end-use parts. High precision samples or parts, that is also what we can cover. We have a new printer, it is called the Desktop Metal Innovant X. We have a very small sample also on our table. It is a kind of gripper for an endoscope. Yesterday in Zvika's presentation, you have seen this gripper also, and it is a part what normally is machined out of 10 different pieces, and we printed this in one. Between the grippers is a hinge in, and there's a space of 0.09 millimeters. From there, you can go also either additional machining or then different end-use parts. Just one or two slides about these printers, what we have. So that we have here this studio system. Studio system is either for low volumes or also a very good printer for the EDU department. What do we have? We have bounded rods. The powder is bounded in rods. The powder has a size of 25 microns, so you can handle it very, very easy. You don't need any self-protection equipment, nothing. It is just put in sticks, and then we put this into the printer. It's running outside. You can use this everywhere. You don't need any tools. So good for low volumes, good for shop applications. You can use this in your office, and also then a perfect solution for EDU. For EDU, we sold a few of these printers within the last month. And after the printing process, you go into the furnace and do the sintering. Very, very easy. So it's more or less just in 2 steps you can get then your final parts. Mid-volume or bigger volumes, therefore we have this shop system, what I said before. Shop system, You normally see just the printer itself and the furnace, but it is a little bit more of what you normally see here. So we have a powder station, we have the activating oven, but here you can handle directly, or you have to handle directly the powder. That is something I will always say if a service provider, a customer wants to earn money, then this is a best solution for him, because there he can do a mass production. And also, if we work there with a service provider, if we choose somebody there, then we recommend also that this company has its own CNCing machines to finish then the parts. Equipment is that here how is it here? So on one side here is the powder in, then the build envelope, and then this printer just makes a combination between the binder and the powder. No heat in this printer, nothing. We activate then the complete mixture in a separate oven. So, and we can say here, based also on that production scenarios what we have, that we are roughly 10 times faster compared with SLM, with a laser-based solution, also with powder. You can do a mix, you can do a batch production, you can do a medium or a large production. So we use this printer very often also for this mixed build envelopes, if we do some benchmarks then for our customers. Then you can mix different parts in one print shop. The third one, what I want to show you, is also this new one, the Anisoprint, an FDM printer with endless fibers. There, Lutz Feldmann will do then the presentation, especially for this one. It's also a turnkey solution. We want to use this for jigs and fixtures and also for grippers. The main thing is the printer what we have outside is an A4. The advantage here, you work with endless carbon or basalt fibers, and then you overmold it. Details will follow from Lutz. Yeah, and then you can print there some parts as you need for your production. Two different sizes, an A4 size, an A3 size. Some examples in the next slide. So cutting head, I think that is not something new. You have seen this in several presentations. Also in the presentation of Emil, you have seen it. What we in general do is, if you have to machine some areas at the end based on tight tolerances and so on, then we add there, and that is where we have these red areas, we add there more materials that we can later remove the material there to achieve then the tight tolerances. The same what we do here is also with the bone plate. With the bone plate is always the question, or in general, our philosophy is that we design a part that it's later easier for a machining process. Here you see with the bone plate, yeah, you can either, if you go to a service provider and service provider is printing that for you, then you get just the bone plate. We add an area here for an easy fix in the machine, in the CNCing machine, and that is something what we printed here or also machined in our tech center in Schramberg. In total, you can, there is on the bottom line is written down 280 parts. 280 parts same, but also possible for us 280 different parts. So you can really do it like customers need, like a patient is needing it. Surgical instruments. Also, these are numbers what we got from our customer. In that case, for example, it is Rüdischhauser. Yeah, he is using this, he is machining this part here on a CNCing machine. You see here also the costs for the complete part, for the complete surgical instrument. And then he was asking us that lower areas here is always the same. Can we use their additive manufacturing? Can we use their 3D printing? But on the upper side, where the clipper is, there we have to do something custom specific. And that is what we decided here, that we made a blank, and then he can machine it at the end on his own machines. One of the last samples what we have here is also, it's a kind of dental forceps. That is something where you see here with eye machining, the machining time takes around, just for this insert here, takes around 25 minutes. And in combination then with additive manufacturing plus final CNCing, just machining there where it's necessary, it takes just 8 minutes. So the customer is saving 17 minutes per part. And if you calculate it on your CNCing machine, in total, if you have to print 500 sets, then it's around 280 hours in saving. Another possibility here also is for material reducing in combination with that one, then it is just needed or you can reduce here then the need of material. Sample what you see outside is then also what we did with this milling or with this rocker. It is printed, and then at the end, you see here how much it costs if we do this with aluminum. And then on the next slide, you will see how much it costs if you do this with 3D printing on our Anisoprint. So that was more or less one of the last slides. I have to save some of time. Yeah, and so I want to come back to my questions from the beginning. Do you think that additive manufacturing will replace CNCing? I will say no, based on the tolerances and also based on the technology. So it will be also the future that we have these combinations of 3D printing and the existing CNCing technology with SolidCAM software. And what are the reasons? The main message is you have your own customer base. You can offer this to your customers. You can be more, then a little bit more work as a partner. It is not something that you have to discover new customers. Just offer 3D printing, choose the right customers, offer that to your customers, and then you can create more margin, more revenue, and also being a more interesting partner for your customers. Thank you so much. Yeah.
Okay, when you see it in his presentation, everything looks easy. It's very difficult. Why? Because CNC machine shops are used to buy CNC machines, and they know how to do CNC machining. Now you have to teach them how to use this technology. It's not easy, but we have a great guy doing it. Good luck.
Thank you. Before I leave the stage here, Linda, would you please come up to the stage? Linda has seen a special printed part, I will say, I don't know exactly whether it was on the AMO or on another trade show, and she was also always asking, she has seen a kind of dragon. And she was always asking, when would I get my dragon?
Wow, I've been dreaming about it.
So it was a little bit a longer lead time, sorry for that. But now I think we have one.
Really?
Yeah, Christian from Technical Sales. He will bring you a small gift. So that is, it is printed on a shop system, and then this.
It looks even scary.
The base is, but it is completely.
It looks so real.
It is completely flexible, so you can move it, and Important is also the red eyes in SolidCAM colors.
Wow, thank you, thank you, thank you.
Take a picture.
Yeah.
Yeah. Wow, this is so exciting. Thank you. Thank
Okay.
you so much.
Should we take it?
Yeah.
Okay. You want to have it here? Should we take it? Okay. Yeah.
One more thing before I ask the next question. We are running a little bit short today because of the times, and we have the cruise in the evening. So let's try to shorten the coffee breaks to 20 minutes and not 30 minutes as written, because we have to finish everything and make it in time for the cruise. So please try to come back after 20 minutes. And now for the next question. Whoa. What types of SolidCAM operations perform part transfer between spindles, move the machine components, perform manual tool changes? The four answers are multi-channel synchronization, machine-controlled operation, or MCOs, HSM operation, or multi-blade operation. Shall I repeat the answers? It's okay. Good luck.
So, now it's me. First of all, thank you very much for having us here, SolidCAM team, and in particular Emil, to invite us to this very good show so far. My name is Lutz. I'm the Vice President of Europe for the company which is shown here. It's called, and I spell it correctly, Anisoprint. So that's what I've learned so far. Well, let's get started with this little analogy here. Skyscrapers. Millions of them are built on this planet, and we all ask ourselves, how does this work? Trillions of tons of concrete building upon each other? It doesn't work, because it only works because of this. But the secret of this steel reinforcement of skyscrapers is not only that they give stability, but they also distribute the forces internally in the structure to non-critical areas. So it's actually, this is a science in itself. Why did I show this? Well, because in a lot of industries, we can actually see a kind of revolution when it comes to digital things overall. So talking about inventory, I mean, inventory is a huge cost factor in industry, and nowadays a lot of companies already went from physical to digital inventory, talking about production cost. I mean, you face it every day in your conversations with your clients. They all aim to have lower production costs with their machining. Manufacturing, I mean, we experienced it personally in the COVID crisis that we had the supply chain issues, and now more and more companies moving from offshore to local production. Logistics, from global to last mile. We want to avoid longer logistic cycles with our physical goods. And for instance, this is true for all the lifetime I spent in this industry, production development needs to be pretty fast. And demand planning. going from uncertain to predictable. Well, 3D printing does not solve. I'm not here to hyping 3D printing again, because I think we all experienced the last almost 40 years that it was hype, disillusion, hype, disillusion. We want to solve very, very specific problems, and that's why we are here. For your clients, I mean, yes, it could lower production cost. It could free up machinist talent to do the more precious work in the workshop. Improve profitability, have shorter product development cycles, faster changeover and product scaling, and reduce downtime of the machines. Now let's dig a little bit deeper in our technology, and you can visit it outside in the exhibition. So we are, first of all, an FDM printers, which is kind of pushing plastic through a nozzle and laying it down layer by layer. But our printers have a second nozzle besides the plastic nozzle, and this nozzle is shown here. So what they do actually is they transfer a reinforcing fiber, which in our case could be carbon fiber or basalt fiber, which is a natural product, through this nozzle, and on the side we push plastic also in it. So it is kind of a co-extrusion of plastic with continuous fiber. And we have a little cutter there, because from time to time you need to cut this fiber to lay down the next fiber routing. What it also does, we allow our customers to do so-called free fiber placement. So on the right side, for instance, you see a fiber placement which is specifically done in this part to catch up forces at certain points. So almost the same like the steel in the concrete, where it distributes the loads. We can do this. But even more, on the left side, you see that we can print internal lattice structures. So if you want to have an ultimate strong part with physical properties like aluminium or even steel, you should potentially start with this kind of lattice infill structure, because lattices also distribute forces equally in the part, in all directions, by the way. What we also can do with this is, and we currently applied for a research license for SolidWorks simulation, that we can place fibers actually at the point of need. I think this illustration shows it quite easily. Think about this part is held in the middle and pulled on the left and right side, and the fibers we laid down actually catch exactly those forces where the part gets pulled. The research license aims, in a sense, for getting into SolidWorks simulation, figure out the stress distribution in the part, and automatically give a fiber routing pass into our slicing software. So that's what we aim for, and we just started this process. We also support an open material system. The only material which you are required to purchase from us are the fibers, the basalt fibers or the carbon fibers. With the plastic materials, you are absolutely free. I'm a firm believer that, I'm a plastics engineer, by the way, so I'm a firm believer that there is a reason why we have 100 types of plastics, because each and every plastic has very purposefully developed for a very specific reason. And not every plastic is good for a CNC shop, for instance. You know, hydrophobic materials which collect moisture and change properties and dimensions are not very good for a CNC shop when getting in touch with cutting fluid. It simply doesn't work. So in this case, you should choose a material which is non-hydrophobic, you know, and reinforce it with fibers, by the way. So you are free in choosing any kind of plastic which is within the specifications of this specific printer, and we have different printer models. We also support our software and materials, so it's kind of an ecosystem which we can give to your clients. Product lineup, I think I can skip this almost because Jörg already mentioned it. These are the desktop series printers. They usually kind of support your industry, your customers. I think these are the right fits for your customers in terms of producing tools, jigs, fixtures, jaws, soft jaws in a very strong way, and not a weak plastic way, but a very strong reinforced way, so they really do what they are expected to. Outside you can also see our new Composer Nova. Specialty here, it has 4 print heads and a print head changer. So again, this allows for more diverse materials. This allows for solable supports, for instance, which you can then print and wash off. Or you can have different types of fibers with different print speeds, because thicker fiber prints faster than thinner fiber. The Promise 500, this is the really, really big machine, mostly found nowadays in R&D of larger organizations and universities. The temperature range and the heated chamber allows for printing high-tech plastics like PIC, PEC and Ultem together with fibers, which is kind of an exceptional way to do it. So aerospace, for instance, and transportation industry in general shows highly interested here. Software is our own development, so we can import STL files or we can import step files directly from your CAD environment and go and place the part and change the orientation, place the fibers and create a G-code file which we later use at our printers. Materials, as I said, we provide the carbons and so far and so on. But the other materials, the plastic material, you can buy from the free market. Like Polymaker is one of those filament producers where you can buy material from. Let's talk a little bit about applications and start with a kind of more a mechanical problem. Every mechanical engineer knows it. The so-called Kirsch problem. I mean, this hole reduces the geometry, and when you pull this part, actually it will break there. So what we did, actually, we prepared a print where we changed the routing of the fibers to absorb those specific forces and stresses in the part, which ends up in, when you do a test for this part, it doesn't break at the hole, but it breaks at a regular geometry. So again, carbon fiber used in a real professional way, I would say, can solve those problems. Also, here's another study from the University of Hamburg, which works in cooperation with Airbus. They think about placing fibers in 5-axis, which we also will support sooner or later together with 5-axis robots. Another interesting research and development, these are cube satellites. They are sent into space in thousands. Small satellites like this. And we can print the frames because weight, when you send something to space, is really of critical nature. Regular parts like this rocker for a mountain bike, they withstand the forces. They replace steel parts, they replace aluminum parts. Again, another example from Formula Student. And here is one which is more from your industry. That's a tool holder, you know. And sometimes you need those tool holders to be very specific for specific or specialized tooling. And then you simply print them overnight. You know, pick them up next day, put them in, and it works. Another example, this is an example from packaging machinery, where we have end-of-arm tools which we use by robots or mechanics. You know, end-of-arm tooling is also a very good application. So whenever you need a gripper which holds something, or let's think about a vacuum gripper where you can actually print the vacuum channels, so you don't need to mill 2 halves and put them together. It's as simple as this. Another example here in turning machines, a soft jaw, 3D printed. It is strong enough to support this process. And the point is, why would you do these things on your CNC machine? So we are competing here with the status quo because we know that machine costs are the critical performance indicator in every CNC shop. The hourly cost of your CNC machine is the most important driver. So we need to think about how we can use this highly expensive machinery for the highly professional jobs. And these small jobs like doing tools, jigs and fixtures could be done by a 3D printer. Though there is immediate value for your clients, they see it. If you educate them, they see that this system is working. Well, and 3D printing is always considered to produce weak parts. No, we don't. Our parts are aluminum grade or steel grade quality in all dimensions. And I did a little calculation just, for having a comparison in cost. If you really calculate a machine with depreciation, power cost, maintenance, tooling and consumables, and to some extent even space, you come to a serious amount of money this machine costs per hour. The 3D printer, he has a shorter depreciation cycle, quite obviously, but still, it's so cheap in production that you immediately would consider, hey, why wouldn't I do things which could be printed, if they are strong enough, on a printer instead of a CNC machine, and use my CNC machine for the real valuable work? So I think your clients will certainly at least think about this possibility. And with this said, amortization is really quick. We have set up a partnership with SolidCAM Additive in Germany, and Jörg just mentioned this. So feel free to reach out to Jörg. He can supply you with information, with materials, with hardware, and education to get in touch with your client. This said, I thank you very much, and Dankeschön.
Anyway, congratulations.
Thank you very much.
When we decided to go into additive, to provide this additive solution to our manufacturing customers, we started with desktop metal, but now we realize we also need Anisoprint for jigs and fixtures. So Anisoprint completes our ecosystem for additive manufacturing. I want to invite Ryan, who is the CEO of Anisoprint, and Fedor, who is the CTO of Anisoprint, who invented this system, to come to the stage. Fedor is not here? Fedor? Anyway, Fedor is outside. You can see him near the machine. Okay, congratulations, and we are going to cooperate together to create the best printer for jigs and fixtures. Want to say anything?
It's a great honor and an awesome SolidCAM team. So like over the last 2 days, I've had a great time, with you and everyone. So thank you again for this opportunity for working with your organization, and we will learn a lot from your rich experience from the industry. And I think together we're gonna do great job, in bringing a new niche for enabling these, CNC machine tools, and we're gonna be successful.
I would say they are very cooperative. We are studying this equipment, testing them, giving them suggestions. So any new versions will be done together. So congratulations again.
Thank you.
Operations that happen simultaneously. So I'm using these operations.
From Michael was one of the best presentations.
Wow, yeah. He's good.
Resynchronize them. I right-click on this and I say Add New Workpiece, and that brings it up here. And then I just click on this sync right here. And I say delete it, and there you go, just like that. everything is synced up. We'll save and exit. All right, so we have all of our toolpaths programmed. We've gone through and we've synchronized everything. So now let's hop into our machine simulation and actually watch what this is gonna look like before we post it. And what's nice here is because we have two machines technically running, I can use the two views to watch everything at once. I love this feature, so I'll select the right side. That'll be my counter spindle side. So all I need to see for that is just my counter spindle tools. And then here on the main side, I will zoom in a little bit and we can run it. Drilling over here, looking good. Boring over here, liking that. Might have to speed this up so this video doesn't take
84 years.
Coming in, doing our finished pass. Looking great. Mill our flats, groove everything out. Come in, it's gonna thread it a whole bunch. Come up with the counter spindle, grab it, cut it off, and there you go. All you have to do at this point to get your program is press one button. File name, we will say shoe spike. And there you go. That is a lot of work you did not have to do to type out all that code. So really when I see this and I think about how much time it takes me to do this stuff longhand, it is just terrible. I've used other softwares before. Honestly, I really got to hand it to SolidCAM for Swiss. This is really easy, so. Before we go, I want to give a huge shout out to Alex Loper for sending me the print and the models for this. This is pretty cool. If you don't know who Alex Loper is, make sure you go check him out at Loper Machine on YouTube. He does a lot of cool videos. He's a really good guy, also an insane athlete. So thank you, Alex, for sending us this. By the way, I took your design and made it into a death machine, just for fun. And yeah, on another note, before you go, our Swiss Academy is dropping in like a month. So make sure you go check it out because I am going to do my very best to make sure that by the time this academy is completely finished over the next few years, that all of my knowledge is on the internet just for you guys. So yep, make sure you go check that out. If you enjoyed this video, make sure you hit like, put a lot of work into it. Also hit subscribe and ring that notifications bell. See ya.
Hello, hello. Please take your seats. We want to start. Please take your seats. We want to start. We'll wait just 2 more minutes and then we'll start. Okay, so till everybody comes here, people have been asking me about the cruise. So we meet at 4 o'clock. Michael said behind the building, there is going to be, that's what he told me, 4 o'clock. Michael, 4 o'clock, right? Right. So it's 4 o'clock, and there's going to be 8 buses, so please be on time, because the 8 buses are going to be blocking the road. So please be on time. Okay, and the winner of the titanium pen is Mark Cleveland. Woo! Mark. Yeah. And by the way, people are also asking me about the bags, the backpacks. So I will have them here. I'll have a few. We don't have any more T-shirts, but I'll have the bags. So come up to me after lunch and I'll give you the bags. Mark, here is the pen. Okay. And the next question is, what is the main technological approach of eye machining? 1, constant step over. 2, constant cutting force. 3, constant engagement angle. And 4, constant feed. Thank you. Good luck.
Yeah, perfect. Everybody, hello again. So, I hope you have a great coffee. This presentation is about what SolidCAM brings in the future regarding to development. And this presentation ordinarily should be presented by Michael Vinetsky, our CPO, and he was prevented to do it. By this, I would like to everybody to give him applause for all the great work that he did all these years. And Michael, hope you watch this one. But first thing, let's talk about a little bit of principles that we have in SolidCAM. First thing is definitely customer-driven development. We hear it here many times that we always listen to our customers. But what is the real network? It is a customer that goes towards you, you go towards us. Of course, this event also allows us to share this information. We are not sitting here only just to work and do parties, but we need to also listen for all the features that you ask for us, and we are here to listen to you and to develop it, yeah? The next thing is staying flexible. I think every one of you now understand the market is changing dramatically. So you need to have a company that also is very flexible. I think all of you have at least one company in your mind now that in the past they were having a very strong product, but because they were not flexible, because they didn't meet the challenge of change, they're not anymore with us, yeah? So flexibility is very important. Professional expertise. In SolidCAM, we do have 15 product managers. In the past, we worked a little bit different, but now we are doing it in the way that each person is expert for a specific module. So is that for the toolkit? Is that for the eye machining? Is that for mill turn? For the 5-axis, 3-axis? We do have product managers, and their job is to make sure that everything that you are saying with all your brilliant ideas that you get also from yourself, also from your customer, came into their ears, and they put it into a product. Now, here are like 420 people, if I understood correctly. I believe that every one of you at least once create a feature request per year. So we have now 500 brilliant ideas that we need to put somehow in our software. So there are two challenges that our product managers are doing now. So with all these 500 tickets that we have, the idea or the role of the product manager is to do handpicking to understand the potential of each of these features, to choose 10 of them and put it into the software. Even though that, let's imagine that, of course, not all 500 it's possible to do, even though the ideas might be amazing and brilliant, but we need to do handpicking on those that will give SolidCAM greatest value, but also the best solution for our customer. Also, what I want to also to say about product managers, one more thing. Even though that was all these brilliant ideas, it's when you have a lot of things that you want also to put in the software. Another challenge is that you don't want to make a lot of changes because that is going to confuse customer also. You don't want your software to dramatically change from version to version, yes? So we need to gradually make changes. So this is the role of product manager in SolidCAM. So, and today I want to show you, I cannot show everything what we are doing, yes, but I will highlight the things what we are doing in the future. That will be definitely mill turn and Swiss type. We know that this is a very important module in SolidCAM. It will be very important, and we are making sure that in every version we put something nice for this module. The next thing is eye turning. I'm going to talk in the next slides also. And also SolidCAM project. There will be more improvements in automation, CAM part for clones, and sequence optimization. So let's dig into each one of these to understand what they are. So let's start with some improvements that we're going to have in mill turn and Swiss type, CAM like very frequently asked feature. So it will be axis on device. Now, this is interesting. Axis on device came to us like very common thing that happens on the mill turn and Swiss. For over here you have a case where you have a revolver, but this crazy machine also inside the revolver it has the B-axis. Kinematic B-axis that when you put a holder on it, it will also use it kinematically, not like positioning, so simultaneously. Amazing, amazing thing. And how we can do that in SolidCAM. So what will be the way how we will do it? Toolkit allows us to do it, yes? So we will make some nice changes inside the toolkit. But this change and improvement is not only going to help in mill turn and Swiss, but we are also looking how to help also in the regular 3-axis milling job, 3-axis milling machines, where you can put angular holder. Many machines can give you the controlled axis, the controlled CNC driver that can run this angular head. So what you are going to do in that case? Another case is like everybody knows Haas machine, 3-axis VF. Let's start from this. You can put the 4-axis device. You can put the 5-axis device there. And where is the big problem, especially on this 4-axis? Many of you met this problem. Whenever you take it, most likely customer don't use it all the time. Sometimes he's using for 3-axis application, sometimes he attached this 4-axis, but for a specific application, he's moving this device along the table. So how we are going to solve this issue? So this is the first challenge that Access on Device project is going to help. It will allow user to put device through the toolkit and allow you to position it anywhere where you want. Also, so this is that case that I just mentioned. Also, provide a support, like a device there that it's always dynamic. You never know where is this position. It will be solved by this case. The next project is something that we call custom turning plane. What it actually means? So supporting, today SolidCAM supports the XZ plane for the turning, but we are looking forward for the YZ plane, also custom turning plane. This is going to, on the top right, you can see the free turn. Probably many of you heard about free turn. Today we can do it, yes, but we want to make it even more user-friendly to support free turn in SolidCAM 2025. And of course, do not forget the YZ plane. Like many Swiss-type machines are doing the cutoff along the y-axis, also the mill turn application. Whenever you have a chance to do a cutoff along the y-axis, you will do it. So this feature is going to enhance that possibility. Next one, we are going to add new tools inside the toolkit. Corner round end mill, back chamfer end mill, convex tip end mill. Convex tip end mill is already coming in 2025. Chamfer with flat end and much more. If you have any requests for specific tools, we are going to add more and more in the future. Toolkit, new parameters. This is, I'm going to again ask Ken, where are you now? There you go. So for many years, and also Doron, when we created this feature in our system, the very first comment came from Doron, like, if I had this feature 10 years ago, I would make many things more better for a helical interpolation parameters. That will be inside the toolkit. So today, what we have is you need to modify that for every single job. The idea is that all helical parameters we are going to put inside the toolkit and pull it from the toolkit. Of course, also the side step parameters and cutting depth parameters will be also inside the toolkit. We are going to add a new turn drill job. As you already know, we support the milling deep drill, but idea also immediately came once we release this feature, say, do we have it also for turning? Oh, no, we don't have for turning. Okay, develop it. Yes, it's very irreplaceable method in the Swiss type. We see it more and more, and this is coming as well. Variable pitch support in thread drilling. Tool stick out for the turning, easier positioning. As you know, we do have option to make outside holder length support for milling holders. That's quite easy to do, but we want to improve the way how the customers are doing also for turning, yes? For turning tools as well. And a lot of requests is coming for the linear and rotary broaching. Also, a lot of Swiss-type applications have this coming with this request. Eye turning. You heard many, many times say everybody's asking, hey, what is happening with eye turning, when this is coming on. So how everything starts. You know that we in SolidCAM we have already trochoidal turning, yes? But trochoidal turning, it's awesome, but you can only support the round insert. So we were thinking about, okay, how we can use eye turning toolpath and technology, but for any insert. So what we are doing now, we are using some equipment. We are building mathematical model. We are predicting the cutting forces and the pressure in order to use any insert geometry. So idea is any insert 3D model geometry that you are going to import, we are going to look for the geometry, select the geometry, and predict the best possible toolpath for this turning job. So this is what it's coming. We are doing on it. We didn't close this project. It's very important. It's a new era of turning, so keep tuned. SolidCAM project. I think it came, what is the main difference? On the very right side, you can see not traditional CAM tree. We are going to enhance it, which will allow us multiple stock, multiple setup, multiple toolkit setup as well. As you know, yes, if you want to go from one machine to another machine, you need to create a new project, and then you often find it challengeable to move the target, move the stock, updated everything, yes? SolidCAM project, or we also call it SolidCAM assembly, is going to allow you to easily go from one machine to another machine, from one setup to another setup very easily. It also allows multi-part functionality, and etc. Automation. Automation, it's extremely important, and the very first thing what we very frequently ask is, the whole wizard. Today we have a good solution, but everybody is saying, can you make it more user-friendly? Yes? We're not going to a solution where, a robust system that the user needs to fill a lot of data, and at the end, one click, it generates everything. So we don't go in this direction, but we're going to, for each specific hole, to give user an options that will pop up to your screen whenever it's necessary for a specific hole type. So we're working a lot of hole wizard improvements. And a lot about the drag and drop templates, process template, it come from you guys, supported folders inside, machine recognition, etc. CAM part clones and sequence optimization. Okay, we already have, in the first day, we had amazing product managers meeting and also managers meeting afterwards, where I highlight what this feature might be. Everybody were shocked. So, can I do this? Would I be able to do this? So, let me tell you what the CAM part clones really are. As you know, we introduced the new features inside the toolkit. And what is very nice in that, because we introduced also the part mounting. And when you have one part mounting, yeah, it's clear you can put one part and that's it. But you can really put now more part mounting points. That will allow you to put multiple parts on it. Let me tell you the best application. It's not over here. Somebody immediately said, we will support Thompsons. Yes. So the idea is that you program one part and you easily, it's not transformation, okay? So don't take it like you need to do transformation. No, you finish your one part, and then with Workpiece Configuration Manager, you can do very easily add a new clones. Now, the greatest thing about it is that for each clone, you could specifically change also a few jobs inside it. It's not like it's completely just clone and you cannot do anything it. No, you can change for each workpiece. We have the Workpiece Configuration Manager where you have all the list of the job. We can see it over here. And you can, like in SolidWorks configuration, you can turn on and off the jobs that are relevant for this part and which one are not relevant for this part. What are the applications? Not only tombstones, okay? I never met, today it's very rarely I see that you go to the machine and you see one vise, you put a part, you close the vise, and that's it. Very rarely I see that. More and more customers like to use complete potential of the setup, placing at least 2, 3, 4 and more vices. The idea that you want to completely finish one part once with one cycle, and many parts. So usually I see 2 vices, 3 vices, and you can now either stay in the same orientation or you can flip, for each side. Everything like this, it will be supported with the CAM part clones. It's coming in 2025. Not sure if it's SP0 or SP1, but stay tuned. This is the very next feature that it's coming to our software. Now we have the sequence optimization. The idea for the 3-axis, what you can do, for the 3-axis, optimize a tool change. Yes, and you already seen this feature available since we have the Sequence Manager. I promised you yesterday that why we changed from channel synchronization. Our channel synchronization was always called channel synchronization, and now it's called Sequence Manager. Yes, so Operation Sequence Manager because of this feature. Yes. That will be it for my presentation, and future is ours to create it together. Thank you very much.
Hello. Everybody hear me all right? I am Greg Payton from SolidCAM. Now, I say that as an inside joke because you might be hearing a lot of that if you watch the Titans of CNC Swiss Academy. But today I'm here to talk about partners and what we're doing with these partnerships globally, how we can identify new partners, and how we can continue to grow with these partners. So one of the things that we want to do as we're creating these partnerships is look for these opportunities to build existing relationships out. We have some great examples, and I'll mention one coming up, where word of mouth from one partner was able to get us in the door of other partners in that region. So if we're working with existing machine tool builders, they can suggest other partners that are synergistic with the energy or with the industry. So things like a relationship with Tornos could get us in the door with the representatives from ISCAR. It could get us in the door with representatives from cutting fluid manufacturers like Blazer or Fuchs. And then we can also work with existing customers to have them recommend to their suppliers using SolidCAM and build out relationships that way. So as we're working with direct partnerships and building out with companies that are machine tool builders like Citizen, Star, DMG Mori, those are the obvious ones that we want to go after. And those are the ones that we really want to push because they can have the most impact on our industry. And then from there, we're looking at building out other supplemental industries, tooling companies like Kennametal, ISCAR, Goering, Hoffman Group, all those great companies that can recommend tooling solutions to their customers and the use of SolidCAM to really push those tools and machines to the next level. We're also looking at indirect partners, maybe somebody that's not directly using our software, but we can pull from their solutions and build out better solutions for our own software. We see that with tool measurement companies like Zoller, or a new relationship that we just built with Omega TMM. So at the IMTS exhibition, we actually had one of these Omega units in our booth, and it was fantastic because it also highlighted a relationship with an existing partner we have in RegoFix. So you see a complete industry solution come together, the tool holding from RegoFix, the tool setting from Omega TMM, and being able to bring that information into the machine. In the case of the IMTS exhibition, this was a Herco machine, but we have a complete solution package all in one partnership. So other ways that we can look at getting new partners that are indirect would be in quality assurance. Companies like Mitutoyo for measuring parts, we can partner with those companies. abrasive processing. Maybe you have a plater doing finishing work on your parts, an anodizer. Anybody that is indirectly related to the industry can become partners with SolidCAM. So what are we going to do to recruit these new partners? Well, the first thing that we want to do is we want to identify. Let's start prioritizing these partners that we want to bring in and help build out this SolidCAM family. Now, we're looking for something that's going to be complementary, like I said before, but we can be creative with this process. Now, once we identify the company that we're looking to partner with, we need to identify the individuals that are going to get us in that door. Now, in a lot of cases, we are a very technical-focused industry, so it's easy to go after the application engineers that work at these companies. We want to get that information. We want to provide them with the tools that they need. So we look at applications managers. But it's also a good idea to get in touch with the sales managers at these companies as well, because they're going to be the ones that are going to be pushing these solutions and handing us leads, and we can exchange that type of information. Once we get those contacts in place, the next thing we want to do is we want to implement the partnership by showing exactly what SolidCAM can do to benefit their company. And in exchange, we can use that as a jumping off point to identify what that company can do for SolidCAM. That way it's win-win for everybody. Now, we've all heard throughout this last 2 days that we are pushing the boundaries of what we can do with the software. And a lot of that is because these machine tool builders, because these tooling companies are coming up with more and more innovations that's pushing the industry forward, and SolidCAM is here to meet that. So one of the things that we want to get from our partnerships is the technical information on how to drive these machines, how to drive these specific tools, and we'll continue to build with them. And by showing these partners that we are willing to be at that forefront and push those boundaries means that we're going to be growing strong partnerships for years to come. And then the last thing, we're wanting to treat our partners almost as if they were customers. That means communicating with them, getting them the information they need training resource-wise if they're using our software. We want to keep in touch and make sure that the software is working well for them. If we're providing them with post-processors, how are those post-processors working? And making sure that they're able to use the software quickly and effectively. Now, some of the new projects that we want to move forward with throughout the end of this year and in 2025 is we want to make sure that the sign-up process for becoming a partner is as easy as possible. We want to make sure that as we bring on these partners, they're onboarded in a very quick and seamless manner. So that could be easy applications, and also building out the learning resources for what they need into a web portal. That way the information is at their fingertips quickly and effectively. This is also going to be getting started information, video, YouTube links. Also, the certification site. There's going to be more information about that later on, but it is a fantastic resource for getting people up to speed and qualifying their knowledge. So having those links that they can access is going to be paramount to their success. Now, another thing that we were talking about, especially when it comes to tooling providers, is we are looking to get our tooling providers implemented into the software. We've already seen that with Amugi Franken, as well as Kennametal, and a couple other tooling providers, where you can access their tool libraries directly from our toolkit. Now, we want to make sure that if additional tooling partners want to put their libraries in our software, they'll have those resources directly available to them on the website. That way they can start building out those libraries. Okay. Now, one example that I want to give is a partner that comes from our APAC region. Now, this is going to be a partnership with SYIC, Shenyang Industrial Co. And what they do is they are a premier tooling supplier doing holders, fixtures, and they are using they purchase the software through a reseller, HTM. And HTM is the one that was providing their technical support. Now, what's great about this partnership is that they initially purchased those 10 SolidCAM licenses, but SYIC is also being a recommender of the software and has influenced other companies to buy SolidCAM. And the reason that they're doing that is because they use SolidCAM with all these different options for tool holding, boring heads, collets, workpiece clamping, a line of angular heads, as well as other cutting tools and measuring tools. So here we've got a brief video. I'll show you a little bit of their tools in action. And then a brief message from SYIC. So with this, why is SYIC a great partner for SolidCAM? Well, it's because we offer solutions from both sides. So for SYIC, they get SolidCAM's advanced features like eye machining. That way they can use our tools, our software tools, to enhance their machining efficiency. Now, SYIC's tooling designs implement high-pressure coolant systems, and that is a complement to SolidCAM's multi-axis machining. So because we have these powerful tools, we can actually get them to program their parts faster and more precise, as well as reducing tool wear with our eye machining and other features. So with HTM, they're able to support SYIC, and that gets SYIC the ability to stay ahead of the game when it comes to manufacturing their parts. Okay. Now, one of the nicest things that I heard when talking to the TC Goon about this is that SYIC is also bringing in other machine tool manufacturers and recommending that they go with SolidCAM. Now, these were manufacturers that in that region were, up until this point, promoting other softwares. But because of the partnership with SYIC through the reseller of HTM, we're actually able to start getting rid of those other CAM softwares and bringing in SolidCAM in their place. Another interesting partnership that we have is one that pushes the technical boundaries. So we were talking about using partnerships to expand upon what we're doing with the software. And so Ivan Simmer and the team in Slovakia been working on developing out with Ceratizit their free turn process. So this is a wildly innovative process. We'll go ahead and show the video for those who haven't seen it before. So you can see that Ceratizit free turn is a process that requires a high level of CAM support. And we're able to do that with our software package because we're working hand in hand with Ceratizit to develop out the processes that are needed. So as more and more machines are going to expand on the capability, because this can only be done on only a few machines so far. But we know that this is going to be the future of turning applications, and so we'll be ahead of the pack and supporting it from the beginning. Now, the next partnership that we have is with Titans of CNC. Thank you, Donnie. Now, this is a partnership that's not necessarily a machine tool builder, even though it did help open some doors with Tornos in the United States, kind of building upon the other relationships that were built with Tornos in the Latin America side, as well as in France with Hervé's team. Now, what's great about Titans of CNC is their reach within the industry. We see that they have a huge amount of followers that are watching all their videos, and that's great marketing for us. But what's really important about the relationship with Titans of CNC is the academy that they provide, the training resources. And by partnering with them in this training resource, we now have the ability to gather the future machinists that are going through these programs. And as they're going through these programs, they're going to be seeing how easy SolidCAM is to use and using our software in the future. So here we see an event that we had earlier in the year. This was their Boombastic event, where we came in and showcased just how dedicated SolidCAM is to not only the Titans team, but to all their customers, prospects, and students. So this was a great event. We had probably 15 people from the SolidCAM US team, and made a huge showing that absolutely embarrassed the Mastercam setup that they tried to have there as well. So lots of happy faces in the SolidCAM booth, lots of sad faces in the Mastercam. So with that, we're going to go to a video provided by Titan himself. Emil, would you like to say some words about it?
Thanks again.
Yes.
Doing a great job. Okay, Jack. Okay, I'm going to say a few words how our relationship with Titans of CNC started. Okay, much better. Okay, so how did this relationship really start? We always knew that Titan of CNC was an amazing sponsor of machining and a great name. Linda was very excited. So in the previous EMO, she took me and Greg, and we stood in a line, meet the man. It was a long line. I think it was in DN Solutions booth. Finally, we came, we shook his hand, and Linda said to him, "You should use SolidCAM." And she gave him a brochure of SolidCAM. It was and a pen, one of those pens. We took a picture together, and then, okay, he met one more person. And then one day I saw Titans of CNC is sponsoring Tornos machines. I said, yes, Mastercam cannot do that. He needs SolidCAM. So that was the start. See here in the picture, in the top left, Greg Payton and Ken Merritt went over to Titan headquarters, and they showed him two things. First, the power of SolidCAM SwissCAM solution, and the power of iMachining. And as you see, Donnie was there. Donnie, who was a long-time user of Esprit, when you saw SolidCAM, he liked it. He's going to talk about it more after that. So this was 2 days of demonstrations that really started the relationship. And after that, Titan became a sponsor of SolidCAM. And the Swiss Academy, this is an amazing project that Donnie and Greg both worked on it. Donnie on the side of the Swiss machines, he was going to show it, and Greg on the side, how do you use SolidCAM to program the Swiss machine. You see here on the bottom right, the launch of the Swiss Academy. We were at the IMTS booth of Tornos. The launch was there, an amazing launch. You see here in the picture, also our Trimec partners, they were in this launch. So I think this Swiss Academy is a game changer in teaching people how to work with Swiss machines. You see here also in the top right, Titan visiting our booth with his team in the IMTS. We had visited before that the Titan headquarters, all our SolidCAM team, before the event that Greg showed. And you see here on the right also the Keith Grano, he's our sales manager of Titan, and he's considering selling SolidCAM together with their SILE machines. An amazing combination. Okay, so Mastercam don't like it, but they don't have a Swiss solution. What can you do? Okay, so Titan now visited, I think, 2 months ago, he visited our headquarters in Schramberg, Germany. And we took him also to one of our important customers, Vonk Muller, and he spent nearly a full day there and created a very nice video about his visit to Vonk Muller. And then he came back to our technology center, and we asked him to film this message that you're going to see to greet all of you, the attendance of this amazing event. Jack, go ahead.
Oh man, the SolidCAM Summit is here. And I just wanted to come in here, get on camera, and give you a special message. And this is going to the resellers. This is going to the employees of SolidCAM. And hey, customers out there, this is for you also. Everything that I have is because of my programming skills. It's because I walked into a machine shop for $9 an hour. They put me in front of a machine. I didn't even have a car before. And they put me in front of a machine that made parts. They allowed me to operate the machine. They allowed me to look at the code and then learn how to program on CAM. And when that happened, it opened my eyes. It allowed me to use my brain and my intellect and everything that I had experienced to actually create parts. When I was young, the aggressiveness that I had on the streets that got me in trouble, I was able to take my artistic ability and put it into the programming. And all of a sudden I realized that although I didn't have a lot of opportunities in life, I didn't have money, I didn't have college, I realized I can do this. And I realized that as I got better as a programmer, I could actually make money for the company. And the more money that I made for the company by actually being more efficient on the parts would allow me to make money for myself and my family. And as I did that, I gained life. I gained opportunity. I ended up, like you guys know, I was in prison. I came from homelessness, and all of a sudden I'm paying rent, I'm buying a car. All of a sudden I'm building a family, and it's because of programming. So I just want to tell all of you guys out there that are working with programmers and those that are programming, there are levels to the game. And what a great opportunity you have as a SolidCAM employee, that you get to speak into programmers like me, like a young Titan that is starting out. You get to speak into them and show them certain toolpaths and show them that by looking and analyzing every single one and speeding up and slowing down and making it more efficient, you're going to be able to make that company money. You're going to be able to raise your value as an employee. And as a SolidCAM employee, you'll be able to speak into these guys and lift them up. It is a great opportunity for you. So when you look at these programmers, understand that you're literally speaking life and changing their lives, and if you can inspire them to be great, that they will be the pillar in the company for the company to be great. I always say every single company is literally run not necessarily by the CEO. The company is run by the head programmer, because it's the head programmer, the alpha of the group, where their intellect and their experiences and how they run the machines, that is what dictates the pace of the entire shop, because the younger programmers fall in line behind that person. So as you guys help inspire and mold these programmers, you're doing a service to industry itself. You guys, SolidCAM, congratulations. You guys are an amazing company. 40 years global, 30 years in Germany alone. Hey, Emil, can you come over here real quick?
Yes.
Oh man, what's up, brother? How are you?
Good, how are you?
I'm good, man. I just wanna say in front of everyone right there, congratulations for 40 years in business, 30 years in Germany alone, and you got what, 300 employees plus resellers. What an incredible company you guys have built. Congratulations.
Thank you, and we had a good day together today.
Super good, super good. SolidCAM in the house, Titans of CNC, changing the world, changing lives, boom.
Oh. I could tell you he's an amazing guy, not only for CNC, as a human being, and being in touch with him through all these months is really a great opportunity. Donnie, the floor is yours.
What is up, SolidCAM World 2024? Let's go! Like Titan said, you guys have been in business for 40 years, and that is amazing. That is awesome. Congratulations to all your success. Emil, Linda, thank you so much for having me out here. I am pumped. I'm excited to talk about our Swiss Academy. Now, I'm pretty confident none of you have ever heard someone say, you know, it's really annoying how many qualified people I have for every single job. It's like I put a post up on LinkedIn, and there's just an endless stream of overly qualified people that can do these jobs. Have any of you ever heard anyone in manufacturing say that? Absolutely not, because there aren't enough people in this industry. There aren't enough people that are aware of what we do, and they have no idea how important it is, what we're all a part of. Manufacturing and the ability to make things is what defines every single part of human history. From the Stone Age to the Bronze Age to even the Industrial Revolution, we look at our ancestors about what they could do. And now we're in a new age, and we have crazy technology. We have a space station going over our head every 90 minutes. I mean, it's insane what we've achieved as a species. It really is. And this academy is so important to me. It is so important to me. I've never done anything like this in my life, ever. And I don't think I'll ever top how important this academy really is. So what we do at Titans of CNC, yeah, we make YouTube videos, yeah, we have a lot of fun, we do a lot of cool stuff. But we also, well, not also, but our main focus is to bring awareness to this industry. We need more people in this industry, but that isn't enough. That is not enough. We have to also educate these people. We have to pass the torch onto the next generation of machinists so they can do what, like Titan just said, put food on their table, take care of their families, keep work in your countries. I think I've heard from multiple people here at this show, there's roughly 30 or 40 countries in here. It's a lot. And you all have to be able to manufacture parts and make things and teach people how to do this. You don't have a choice. You don't want to not manufacture stuff, I promise. It's not good. So that is what this academy is. And as Swiss machining becomes more and more common in our industry, we are going to need to teach more and more people very rapidly how to do this. And that's what this will walk you through. If you go to SwissMachiningAcademy.com, you will find an academy that roughly has 100 episodes. I think it's 101. And it walks you through everything. I mean, some of the episodes for some of you skilled guys in here might be like eye-wateringly boring because I literally take you from a power switch to having a part in your hand. I show you how to set collets. I show you how to set guy bushings. I show you what to watch out for. And yeah, you could learn Swiss machining. And for people at SolidCAM, you know, if you're in sales here, I really think you should watch this. I really do. We had a meeting on Monday, and one of the points I made that I really wanted to kind of talk about up here was if you go to shops and you try to just talk your way through selling SolidCAM to people, and you don't actually know how these things work, you're going to get lit up. People are going to tear into you. I know that because that's what I've done with multiple sales guys from multiple CAM companies. So you should watch this, and you should learn all the little tricks to this trade. It's not that much time. Each episode's roughly 3 to 5 minutes, but it is important that you understand this. It's important that you understand this on an in-depth level because it will help you sell your software. And it's also going to help you teach the next generation of machinists. I cannot emphasize enough how important that is that we do that. They need to know how to do this because they are going to have to teach their kids and every kid after that. They have to learn how to do this. So, I don't know, Greg, are you up on the Swiss Academy right now? Do you have it up? No? You can't? All right, well, you do have phones in your pockets, so if you go to SwissMachiningAcademy.com, you can see it. Now, one thing that's insane about our academy, we have had over 450,000 registered students over the years. That's insane. That's 500,000 people. And the Swiss Academy is really the tip of the iceberg. I'll be honest, before I worked at Titans, I had no idea how much work this guy has put into uplifting this industry. It is truly inspirational to work with someone like that. Honestly, I had no idea. But if you go through our Swiss Academy, you will see everything is laid out. It's very nicely laid out. It goes from simple to hard. So you are, again, you're going to start with a power switch, and you are going to slowly learn every single trick to this trade. So yeah, when you go to our website, you'll see this is what it looks like. You have an intro video with Titan going through the different machines, explaining what you're about to get into. And then as you go down, you'll see it's super nicely laid out. I really love what they did with this. But yeah, look at that. Tornos and SolidCAM on our academy. How awesome is that? It's amazing. All right, so if you keep going down, Greg from SolidCAM, you'll see the fundamentals, and then you go through the advanced fundamentals. So one thing I get asked a lot about this is this applicable towards other Swiss machines? Yes. It will help you with other Swiss machines. So if you are working on a Citizen, yes, the fundamentals, the basics, they're there. You can learn that. Now, obviously, if you understand Swiss machines, they don't really have anything in common as their programming goes. I mean, it's absolutely absurd. So the programming, yes, will be very Tornos based. But this stuff right here, the collets and guide bushings, this is all good for any Swiss machine. The fixture points and all the live tool holder stuff and all that, that is definitely going to be a little bit more Tornos specific because Tornos has their own way of doing things. So it is good, though, that you know that. It's good you know how versatile Tornos machines are. There isn't really another Swiss machine out there that you can, like, you can rip the whole machine apart and turn it into a milling machine. It's wild. So we do go over all that. And yeah, as you go down, you'll see touching off tools. There's tons of episodes on that. I mean, Swiss machines are weird. It's not like you can just call up a tool probe, tool preset, or whatever, and just touch off your tool in one shot. It's not easy. You need tool presetters. You need to do different tricks with paper or shims, or you might not have ground stock. There's a lot that goes into it. And then next, as you go down, you'll see the Tornos macros. Now, this looks like a lot, and actually, the first episode is literally me telling you, don't panic, because this does look like a lot, but once you understand how the Tornos macros work, it actually is brilliant what they did with their machines. It really is. It takes care of so many things for you that in Swiss machining can be a real pain. I mean, they have Torx milling macros. They have macros that feed the part out for you, grab it for you, get the lengths right for you. It really is convenient. So don't worry too much about going through that. But then we get to the reason why I'm here, the SolidCAM fundamentals done by Greg from SolidCAM. If you click on one, you'll get why that joke is kind of funny. So anyways, So yeah, he goes through the fundamentals, basically creating a new project. You have all the basics, right? Opening up your folders, getting all your files in the right folders, all that stuff. Greg will walk you through all that. Now, one thing I want to add, this is not anywhere near complete. This academy, like I said earlier, is like, for me, is the most important thing I've done with my life. And I am not going to stop adding to this until I am confident that every shred of knowledge that I have gained over the years is on this for people to learn. So like thank you. So, as you go down, you'll see the very first part we make. As simple as I could make it. It is a pin. I know, it's not exciting, but it is what we need to teach you first, because the reality with the Swiss machine, there's a lot going on. There's a lot going on. They're confusing machines. So what I was more worried about when I created this was, you know, over the years, I used to teach people face-to-face, and it's insane how quick people gloss over when you start talking about channels and weight codes and all that stuff. They just look at you like, dude, what? So I wanted to create something so simple at first that you could get the confidence to work your way up to the next levels of this academy. So all I cared about with this first part was showing you just, you know, you have to feed for stock. You have to just turn the part, come up, grab it, cut it off, come over, eject it. It's just the bare minimum. That way, whoever goes through this will have the confidence to go on to the next part. Now, the next part is going to be what's called the 2S. Now, every single Swiss machine, well, before I talk about the 2S, every single Swiss machine comes with like 1 or 2 part ejectors. And this is a problem because once you turn them down, that's it. You don't have any more part ejectors. You can't make them any bigger. So what I wanted to do with this academy is create a part ejector series. So that way, anyone who has a Tornos machine can go through this and they can make the part ejectors. And we're going to make different size part ejectors in the future. It's not there yet, but we are going to do it. And you can make part ejectors for your machines. That way, you don't have to worry about this problem ever again. And if you've worked on Swiss machines, you know how big of a problem this is. It's a pain. You're trying to set up a part, and you're trying to get a job running, your boss is yelling at you, and you don't have an ejector for your part. That just completely slowed you down. That's hours and hours of work. Now you have to figure out how to make a part ejector with whatever material you have, whatever's in the machine. It is a problem I've ran into a lot, and that is what I based the academy off of. So here, and if you go through the 2S, I mean, I go through everything. I go through everything you will need to know on how to make parts like this. I didn't cut any corners. I didn't take it easy on you. I go through everything. I even left mistakes in there. When we thread this part, I purposely didn't deburr it because I wanted you to see if you don't go through and rerun your threading tool, if you don't rechase your threads, you'll have burrs in your threads, and you need to know that. But I could just easily show you that and not explain it. But then what's the point? You're not teaching anyone anything, you're just showing them. So I want you to know that before you go into this academy. I was more focused on teaching than showing. It was important that you really saw the burrs. And there were burrs, obviously. I mean, if you turn something, thread it, and you don't come back in, you will have hanging burrs. And I show it on the shadow graph, and you will see what we have to do to make a perfectly burr-free part. But there's more to come. So right now we just have the 2S. And if you go down, right now, these are just like our more popular videos that are on YouTube that are a little bit more technical. You know, there's a macro one on threading, there's a femoral bionic nail, there's thread rolling, there's a whole bunch of stuff you can learn just from our YouTube videos. But in the years to come, we're going to have the 3S, which is your small ejector, your 4 and 5S, which are your 2 different adapters. Tornos has a long part ejector, so I had to make adapters for whatever machine you might have. But that is going to be basically what we right now see as the beginning of the academy, the Swiss Academy. And yeah, I mean, that really is the plan for now. Eventually, we're going to get into macro programming. Eventually, we're going to go over so much stuff in SolidCAM. I mean, I don't want to scare anyone off, but I could easily see this going up to 500, 600 episodes if Titan lets me. I'm not going to stop making them. A, it's a lot of fun. It's a cool job. B, it's important. I mean, this is really important. You know, you go to shops and you see so many people wasting time and losing money because they don't know what they're doing. And it's not their fault. I was like that when I started. I really sucked at this actually when I started. To put that into perspective, the first 4 years I did Swiss machining, I didn't even know what a G83 drill pecking cycle was. If you don't know what that is, it's okay. It is a It's a G code that basically makes drilling in one line. I used to write out hundreds and hundreds and hundreds and hundreds of lines until I walked by one of my dad's Fidels and I saw G83 on the screen and I said, what the heck is that? And then I opened up a manual and I was like, oh, I'm dumb. I didn't know that. It's a drilling cycle. 4 years of my life, I typed out every single line. And I really believe that this will reach so many people and it will save them so much time and so much money. And it will make them efficient at Swiss machining. It's important. It's important we help these people out. Because I don't want to see anyone writing out those lines like I used to, man. I don't. You don't want to see it. It's terrible. Eventually, we're going to go over tooling. Eventually, we're going to go over every single thing you can think of in Swiss machining. And yeah, I'm excited. I'm super excited to get this up and get this finished. By the end of next year, we'll probably have the full part ejector series done. This takes a lot of time. It's a lot of time, but, we got to do it right. Titan always says, I talk to Titan all the time, he always says, our academy's free. Free is expensive. Our full academy, all of our part series, all the schools across the world that are using it, that cost millions of dollars to make this academy. Let me ask you something. If I gave you millions of dollars, any one of you, would you take that millions of dollars and just pour it into the manufacturing industry? Probably not. Most people would get in a Ferrari and go right over the coast. And I wouldn't blame you. But Titan has taken so much of his money and so much of his time to create this academy. And I really want to emphasize again, this is a small piece of the academy. The Swiss Machining Academy is a small piece. We have schools all over the world that are using our curriculum and teaching kids. It's crazy when these people come up to you and tell you their stories. It's unbelievable the lives we're changing. And it's cool, right? So Michigan, in the United States, our academy is their official state curriculum. And it is pretty cool because every single day we see people on LinkedIn, on CNC Expert, whatever, we see people posting pictures of parts they're making at their school. Instead of just watching videos or something, these kids are making real parts and they're putting them in these briefcases and they're showing up to jobs saying, hey, I can at least do this. I at least have the basic knowledge to do this. That is leaps and bounds ahead of where we were just a few years ago. So that's insane. And that's just Michigan. And like I said, when I talk to Titan, it is crazy because he always will say, this is just the beginning. Eventually, every state will use our curriculum. Eventually, every state is going to be seeing SolidCAM's Swiss Academy in their schools, and that will be the official curriculum. This is just the beginning. And yeah, it is cool. You guys were bringing up Boombastic earlier, and I had no idea how important what I was doing was. I had no idea. And then you have people come up to you literally crying, saying they watched a Titans of CNC video 4 years ago, and it changed their life. They went onto our academy, they learned CNC machining, they took their money, they bought a machine in their garage. 4 years later, they have 5 machines. Now they have 20 machines, 20 employees, and it's because of this. I mean, I have goosebumps just thinking about it. That's insane. What I'm a part of, what we're a part of, it is insane. And yeah, it's a beautiful thing. It's a beautiful thing to be able to affect lives. It's a beautiful thing to be able to teach people how to put food on their table. We're all lucky in this industry. It is the most important industry in the world. I don't care what it is. Something in this, everything in this room was affected by a CNC machine. From those lights, those speakers, that podium, in some way, shape, or form, a CNC machine was involved. And that is what all of you here at SolidCAM are involved in. You are involved in a software company that is improving every single year, that is shaping the future of this industry. If you don't know that, you need to know that. You should be proud of what you're involved in. And now you're partnered with us, and we are together going to create an academy that is going to change lives. I personally can't think of anything better than that. Now, a lot of you are a lot bigger than me, so I'm not going to go past my time and prevent you from eating your lunch. So,
I agree with you 100%. This is a game changer. Seriously, nobody in the world has done anything like that. Complete free training of the most complex machining.
Yeah, it's awesome. And I'm honored to be a part of it. I can't thank you enough.
Okay, so Come, Greg, let's have a picture together. Let's put you in the middle.
I don't know if I should hold the mic or.
This is Greg at SolidCAM. In today's video, we're going to go over
Here we see an
creating
example
a
of
new
Edditive.
project in SolidCAM. In our previous video, we went over the installation of our supplemental files, getting the machine files necessary for use in SolidCAM. So now we're going to use those files to create a new project. So to create a new project, we need to bring in a 3D model into SolidCAM and SolidWorks. And we can do that by coming up to File, Open, and navigating to the 3D model that you want to choose. So for this particular case, we're going to be using the Titan 1S part from the Getting Started files. I'm going to go ahead and open that up. Now, once we bring the file up, you can see that across the ribbon bar here, we have a lot of different SolidCAM tabs that have all the operations that are available to us. Now, you'll notice that they're all grayed out right now. That's because we don't have an active SolidCAM project open. But once we start a new SolidCAM project, we'll have access to those operations and icons. So to create a new SolidCAM operation from this 3D model, we're going to navigate to the new icon up at the top, and we're going to choose what type of operation we're going to be doing. So we have the choice of milling operations, mill turn operations, strictly turning operations. We also have milling of STL files, as well as our wire EDM module. Now, because we're going to be working on the Tornos GT Swiss machine, we're going to need a combination of both milling operations and turning operations. So we're going to select mill turn from that drop-down menu.
Say one thing, just one thing. That is how Greg starts every video. And everyone at Titans of CNC says when they see him, they go, oh, hey, it's Greg from SolidCAM, because he starts every single episode the exact same way. It's kind of an inside joke at our company. So.
And by the way, as I see here, you can use it to train people on SolidCAM in general, not only on the Swiss. And there was one suggestion made by Donny. I would like all salespeople to adopt. Study those lessons, and then you can much better explain to your potential customer what is Swiss machine.
Yeah, honestly, I think they could help. I really do. I think they could help you guys sell more software.
You become the most expert salesman of Swiss machine in the world.
Yeah, if you go through all this, I promise you, you're going to know more than anyone at, I don't know if I should name drop other companies, but anyone at the other software companies. None of them understand this on this level, so you will have an unbelievable advantage.
Okay. Enjoy. Thanks again.
Vonk Muller, third generation machine shop. Crazy CNCs, crazy automation. These guys are making incredible parts for all industries. A lot of times when I come to Germany, I'm actually showing you monster companies that you are familiar with, like Heimer and Heller and Schunk and Blaser and these big companies. But I'm excited because this time I'm actually showing you a real job shop that is for hire, meaning anybody out there that actually has a part that they design, you can give your prints to this company, they will quote it and they will machine it for you. Now, Vonk Muller is actually a SolidCAM shop. So SolidCAM is the CAM system that they use to program everything from their Swiss machines to their big CNC machines. SolidCAM is basically solving all their problems. I'm here with Toby Vonk Muller at his beautiful machine shop here in Germany. Third generation machinist, shop owner, and you guys do all industries. How many employees?
Workers, 24.
24 workers?
24 specialized.
Thank you for having me.
You. Thank
so
you.
Good? Awesome, man. That's the oldest machine right there.
From the grandpa.
That's awesome. Oh man, manufacturing in Germany, baby. I got Tomas right here on the Mazak Integrect. We got parts, material stacked up over here, and manufacturing, baby. No matter where you are in the world, manufacturing is the same. CNC machining is the same. The language can change, but you're still programming off G-code, all that. I love it, man. I love that YouTube allows me to go into any shop literally in the world, and I'm family with everyone. I know everyone. It's super cool. Awesome. One of the cool things about Vonk Muller is that this is a third generation machine shop. Amazing company, amazing people, super high tech. They're running lights out, running all day long. Amazing, beautiful machines. It's fully air conditioned. Super good.
That's my baby.
Yeah, it's your baby. What's its name?
In English, Caroline.
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 Ah, Caroline, that's the machine, that's his baby. No matter where, like everyone, all machinists have names for their machines, and you gotta take care of them. What's up, Tomas? How are you doing?
Good.
Good?
Good, I'm good.
Oh man, so you're over here programming with SolidCAM?
Yes.
So what's it made out of? What type of material?
Aluminium.
Aluminum?
Yeah.
Like 6061?
Yes.
Okay.
Yes.
See, we're in Germany using SolidCAM, making it happen. Tomas, super good, man. G-code, baby. Boom. Now you got Swiss machining over here.
Yes.
And then you guys use SolidCAM. And then basically simulate everything on SolidCAM, program everything, and then everything runs right here. So it's all like one system.
Yes.
Is everything programmed on CAM, or you guys do hand programming too?
No, over SolidCAM.
100%.
Yeah.
Awesome.
From the beginning, only SolidCAM.
Awesome. You guys love it? You guys teach everybody, and
Yes, yes.
all super good. Oh man, what's up, Greg? How are you, brother?
Good to see you. Good to
Oh
have you here.
man, yeah. Hey, so we're at the Tech Center here in Germany for SolidCAM, and we're just breaking in real quick to announce the new Swiss Academy. And I'm excited because Greg is a guest teacher on the Swiss Academy. We're teaching all the variables, we're teaching the fundamentals, we're teaching how to actually program parts start to finish in SolidCAM, and bringing in the experts.
Yes, happy to work with the experts at Titans CNC with Donnie.
So good.
Bring you the best knowledge for programming these Swiss machines.
Everything, like you guys get SolidCAM, everything you need to know, you'll be able to learn on the Swiss Academy and learn Swiss machining, all of it. Boom, back to the tour. You saw what it did, huh? It went over there, it drilled the 2 holes, and then it went and measured the tool to make sure the tool was still there. And now it's continuing with the process. So when it's lights out machining, that's something you have to think about, like, did the tool break and stuff? So they're doing a nice little check right there. So You machine it, double check it, you keep going, you probe it, double check it, keep going, and that's how you can do lights out, and you can ensure that you're not breaking tools. You're not gonna come in and have a whole bunch of scrap on the table, just running by itself. Oh man, shout out to Studer. Look at that, we got a Studer over here.
This is the center with all the tools.
So this is where they put all of their tools. All the tools, everything for setups are all right there. And then they call them up over there. We saw like a similar system just like this when we were at Heimer, and they basically call everything up, and then it brings the drawer up to the machinist. He can grab whatever chuck jaws that he needs for a setup and then take it to the machine. Tooling, setup, pieces, all of it right here. Even like machine shops can like learn, even the way they put the wood on top and then they strap them. That is clever, and it keeps everything protected. Strapping is great, the wood is great. I love that no matter where you are, you literally, manufacturing is manufacturing, man. People are people, tolerances are tolerances. Beautiful, beautiful shop. He's very proud of the air conditioning system and how it just keeps the air circulating, and it's just nice and cool in here. A lot of companies over there, even the hotels, like you're at the hotels and there's no air conditioning, so it's a little different. Oh man, we just finished at Vonk Muller. Absolutely insane, amazing machine shop. And a special shout out to SolidCAM. You guys rocked it. Man, these guys are using your CAM system to program everything in here, solving huge problems. Crazy solution. Thank you guys so much for your generosity and your hospitality. Boom.
Today, I am going to show you an insane process that has tons of technologies we've never shown before. We have inserts we've never used before. We have softwares we've never used before. It is going to be crazy. Come here. Now, we ran this part out of brass so you could watch it be machined. The actual part's machined out of aluminum, and we had to use coolant for that, which looks like this. You can't see anything at all. We tried to run one without coolant, and this is what happened. Not great at all. Now, the part we're making today on our Tornos GT32 is a part for an aftermarket fuel injection system. Now, this part has a bunch of different specialty features on it that required us to use specialty tooling in all sorts of different applications. So there are three big things that... My fingers are so weird. I can't use my hands, dude. Like, there are three main things we're gonna talk about in this video. Number one is gonna be our PCD inserts that we're using. They worked phenomenally well. Number two is gonna be all the different crazy holders I have in this machine. Really, that's insane. And the last thing is gonna be the new software we're finally showcasing on this channel that programmed this part. I learned it in a weekend. It is super simple. I love it. First up, PCD inserts. Let's check this out. All right, so this PCD insert is insane. But before I go into that, make sure you subscribe. We're almost at 1 million subscribers, and every one of your subscriptions helps. We really appreciate it. So enough of that. Check this insert out. Horn actually put a chip breaker somehow in the tip of this PCD insert. I don't know how they did it, but I was really impressed. On the ID and the OD of this part, I threw these inserts in there and got a perfect micro finish. So for the small tools game, PCD inserts from Horn worked really, really well. I gotta hand it to them. And now on to the next thing I wanna talk about is the holders. This system from Golden Bolt, just being able to throw these tools in like this is really, really easy. I was impressed by how I was able just to put my tools in here. I added one cross hole to them, and all the coolant comes through the front of the tools. I don't have to have any lines in here or anything. But the next holders is what I really, really want to talk about. So if you look up here, you'll see that we have two new live tools that Horn supplied us from W&F. One of them is a speeder. So I had to make a really deep, precise pocket with a small end mill. And the issue with small tools is your RPM, your surface footage. But with this 3-to-1 speeder from W&F, I was able to go 18,000 RPM as I spiraled down that square pocket, which made it so I can go a lot faster. So what does it mean exactly when I say a 3-to-1 holder? So it means for every regular revolution of a live tool holder, this holder will spin 3 times. And that is what allows you to achieve higher RPMs. I'm going 50 inches a minute in the footage you see there. Another thing I like about them is how they're quick change. I'll say this 1,000,000 times on this channel. Anything in a Swiss machine that makes it so I don't have to wrench inside here and bust my knuckles is gonna get 2 thumbs up from Donnie. And with those holders, I'm able just to pop loose 2 screws, take out the head, change the tool in my hands, and then pop it back in. That's amazing. And they run out really, really well. I was surprised at how straight the square pocket actually came out. So good job, Horn. Your products rule. So the last thing I want to talk about for these holders is if you look on our subplate. Horn hooked us up with some really nice graph tools that are interchangeable between the stations and have all sorts of different grooving, threading, turning, whatever, you name it. So it's really nice to be able to have such a compact system in here to allow the maximum amount of tools on my subplate. And yeah, that's it for the holders. Now, for like the grand thing I want to show you in this video that I am the most impressed with is the software I use to program this part. So let's go to my computer. I gotta show you how this works. All right, so as we walk to the computer, I want to drop a little disclaimer. I only learned this software over last weekend. We have not done our official training yet with SolidCAM, and I cannot believe how easy this software was to learn. Everything I'm about to show you is impressive, but the fact that I could teach myself this software as quick as I did is by far the most impressive part. So let's dive into it. All right, first things first, take a look at this. SolidCAM is inside of SolidWorks. So normally with CAM softwares, you need another CAD software to draw your parts, and then your CAM software programs it. Well, with SolidCAM being inside SolidWorks, that completely alleviates that problem. You now have the best CAM software integrated into your CAD software. You literally can't get any better than that. So check this out. We'll go over here and we'll open up our part. So you'll see right here that SolidCAM is actually integrated into SolidWorks. So as you can see our parts right here, and you can see my machining tree over here, and this is where all my operations are for SolidCAM. Now here, if you want to see where all the weight codes are and stuff, that's in our operations sequence manager. This is where we're going to show you eventually how to sequence all your parts with all the weight codes and all of that. It's important to note here that the whole program works. I see a lot of people out there using CAM softwares and cutting and pasting their code to make it work. This posts a good program. All you should have to do is enter your program in, and that's it. You shouldn't have to do anything more than that. To check out our simulation, one thing that I think is kind of cool about this is I click Setup, hit V, and you'll get this simulation menu. Now what's cool is you have the turning simulation, which just shows basic turning. So like, you know, if I want to watch like your regular, just simple 2D, no nonsense kind of simulation, I can just pop into this real quick and check it out. Or if I want to take it to another level, I can hit stop. Let's go to our machine simulation and actually watch the cool, full-blown simulation of our machine run. So it's gonna load everything in, it's gonna load the machine kinematics, all that. Okay, so check this out. We are in our machine right now. You can see all of our graph holders over here. Yeah, you can see pretty much the whole machine simulation. So we can press play and run it. So you can actually see both heads cutting at the same time. But yeah, we got our milling going on down here, just like in the machine. We have our turning going on over here. Speed that up so you can get to the milling. You can see the milling just like we did in the machine. Here's our pocketing. And some of the cool things about SolidCAM 2 I'm gonna finish up on here is how easy the machine is to set up. Other softwares can be a real pain for this, so let's check this out. We have our toolkit here. Now let's say I wanna view a tool, right? So I'm gonna see like this tool right here, all right? I can actually go over here and view what it looks like in the machine. So right here, I can actually see what this tool looks like in the machine, and it shows me the fixturing points, all that. But like, let's say I want to make sure, you know, this tool might not be sticking out far enough, right? There might be something I don't like about it. Well, I can actually go in right here and roll my mouse and move the tool in and out to get it exactly where I want. I don't have to set up my tool, pop into my simulation, see where it is, pop back into my tool menu over and over and over. I can just do this right out of the gate. The setting up of your machine in SolidCAM is light years faster than anything I've ever seen. And let's say I want to see what like the machine's gonna look like if I move it around, right? So I can go onto my B axis, let's say, and I can actually swing it and see how things are gonna clear. I can go into my X axis and see how things are gonna clear. I can like literally play with the machine as if I'm at the control, which is cool. I've never seen anything like that before. So I gotta hand it to you, SolidCAM. Your products rule. Oh, look at that, and you can see the Tornos fixture points. But if I go too far, oh no, it's killing the other spindle, stop, oh my God, oh my God. So that's a really brief overview of SolidCAM. Again, I can't believe it was so simple that I could learn it in a weekend and program this for this video that quickly. I really gotta hand it to him, it's impressive. So stay tuned because we're gonna be showing you a lot more about this software. There are a million more impressive things I really can't wait to bring to you in future videos. So that is it for SolidCAM in this video. That's it for our video today, guys. I hope you enjoyed it. Just want to let you know, and I didn't tell you this, we are working on the Swiss Academy right now, so stay tuned because this year we are going to be showing you guys everything on a Swiss machine. I hope you enjoyed this video. If you did, make sure you hit that like button, subscribe, and don't be stupid, ring that notifications bell. See ya!
Hello? Everybody, please take your seats. We have to start. And I hope the winner of the next titanium pen is here. If not, it will have to go to the next person. So is Marco Lesh here? Marco Les. You're here? Ah, okay. There you go.
Thank you.
Thank you. Okay, the next question is an easy one. In which of these CNC machine tool companies do not offer a Swiss CNC? Citizen, Star, Haas, or Tsugami? Again, Citizen, Star, Haas, or Tsugami. They do not offer a Swiss CNC. Good luck. Oh, by the way, whoever did not get a bag, I will be behind this door when the lecture begins, and I will give bags whoever did not get a bag. Thank you.
No, I don't need it. Yeah, thank you. Thank you, Linda. No. Yeah, thanks. Okay, hello everybody, me again. And this time I'm coming with a presentation. It's not a presentation, is it a live demo about what's new in 2024 and new features. Of course, we are limited in time a little bit, so I cannot show you every single detail, of course, but I'll try to demonstrate to you what are the main ones that are kind of very close to what we have done in the Milton and Swiss. And I'm going to do it lively. Are you ready? Basho? Did I say it correctly? Yes? Yeah? Nice. All right. So where is my, okay. So what I prepared here is classic Swiss type part. I'm using it on webinars. And the machine that I'm going to demonstrate a couple of features is I will do it in the Tornos machine. And you heard in this event that we are also partners with the Tornos, our excellent partnership with Titans, also Tornos, and all this synergy there. And I'm going to demonstrate you with their latest machine, which I really like. We did it together with Tornos. This is I call it monster machine. It has a 3-channel. It has everything that SolidCAM can support. It has linear gang. It has rotary, it has spindle, and also, what is so special about this machine? As you can see, this is the linear gang, this is the first channel, there is a rotary, this is the second channel, and you have the back tool post, and this is a third channel on this machine. Now, what is so unique about this machine? It has the B-axis on the revolver. And how it looks in machine simulation over here. This is the work we have done together with them. Amazing cooperation. I will hide just the housing. So what you've seen was in machine preview, and this is one-to-one when you see it in machine simulation. And let's start with a couple of features that we have inside a toolkit. So I have no job any. I have completely empty machine. I'm going to open my machine preview, and the very first thing what I like to do is to load my tools. So the easiest way to do it, yes, for Swiss-type machines, it's very important that you load your tools as quick as possible. There's a lot of tools here, the library. You want to fill it with all tools, and you can, in Toolkit, what allows you is to predefine the setup for your machine, and you can, not only for one configuration, you can define many configurations for your needs. So what I prepared here is just the TLM, and all the tools are already mounted here on the left, but not also on the right, yeah? So what I'm going to do, how easy it is to do it in SolidCAM, I'm going to use the option here, right-click, and mount all tools to machine. Dynamically, you can see on the right side, the magic happens. So nice, huh? Come on, give. So what is easy layout switch? So I can go right-click to any component, and I can select the tool component that. What SolidCAM is going to do for us, is going to select that specific component. You know about this feature already, yes? But what I like about this is that it's easy to mount it from this to that one. So I can go from 31 over here, I can just mount it to 30. And that's easy, yeah? But what if I want to go from 30 to 29? No problem at all. I go, I switch, I found the 29, there I go. In seconds. I don't know any CAM software that do it so fastly in their tool table. Let's try to do something else. Over here, I have the empty station 28, okay? So let me add a holder to it. So I'm going to click on the holder library and just put straight holder. So it's on 28. There we go. I just drop it. There's nothing in here. There's no 3D data inside. It's just a component. Sorry, my mouse is also a little bit crazy. And what I will do here, so I go to my topology, and I see it's 3D model. There is no data inside. So which one I'm going to use? So let's just pick something from the library. I'll go to the Swiss Deco. Let me just zoom in this for you so you can see it better. So I'll go to Revolver, and let's say I'll just choose this Radial Muller. There you go. I'll just click and open it, and the holder is mounted. All right, so I don't need machine preview anymore, but now I'm going to focus inside my tool viewer. What is so important in this version release is that the way how we define joints. As you know, the joints are very important. This is where you are really connecting with the machine. This holder specifically, the coordinate system that you can see there, connects this holder to a machine station. But another joint we need to define where actually our cutter will be located. And in the past, this is the thing that you do. You go to a connection here, and this is where joint. And for a joint, you're going to find your position where the cutter will be. So far, the way how we were doing it, you have this measurement option, and you can measure it. There was also an option to select the coordinate system if you already have it in K data. But now what we did in SolidCAM is that we allowed that to pick directly on 3D model. How this looks, as you can see, this coordinate system goes along X. So what I want to do here is just simply move it to this surface over here. How to do that? It's fairly simple. Just click on the X because I want to move it along the X, and just click simply on the surface. That's it. simply as that. Another rule that we have, as you probably know, the cutter for the milling tools, Z-axis, it must be followed by the Z-axis, yes? So as you can see, the orientation is not proper for this. What I want to do is to orientate my Z-axis to go towards, axially with this. And there is a couple ways to do it. I can just go over here and just rotate this coordinate system, put the value in, or simply click on the Z. It represents the Z vector, and it will do normal to that surface. I'll just click on the Z, click normal to this surface, and Z will go there. Very easy, yeah. Another thing that I want to show you here is that, let's imagine that over here, yeah, actually, I can show it in this example. I'm going to select this tool component and just open it in the preview. So as you can see here, this holder already have three mounting points on which we can put additional components. And they are already properly named. And the change that we have added is that for each, especially in this case, it's not a perfect, yeah, but you can, if you want to focus to any of the joints, you can hide other joints. You can hide all joints or just unhide the specific one that you want to do. Another feature that I like to show you is that you can use it anywhere, not only inside the toolkit, but also inside a setup itself is orientation and position feature located over here. It looks like this. Very easy, very simple. You have all your filters here. Let me just switch to mounting here. And what you can do, any manipulation with any components, you can do it through this small application. Just clicking on these two surfaces, for instance, just allow the filter. Let me just do it again here. I don't want it here. I want it through Tool Viewer. I hope now it will work. No. That's a problem with the live demonstration, why it doesn't work now. Again, I'll try it again, and then... Oh, let's try it here. OK, so maybe it's that... So click on this filter. I'll just click on that surface, this surface, just I can align it. Oh, I see where's the problem. OK, I click on the wrong component. So first, you need to click on specific component that you want to go in. That was the problem for the beginning. OK, so click on this sleeve over here, and I want to move it. I click. There you go. You click on the filter that you want to have. That's the face. That's the face. There you go. Now, if you want to a specific value, just write here the value. There you go. So easy to mount it correctly, exactly to what are your needs. OK, the next feature that I want to show you that we add recently is in our settings. You have here the toolpath color itself, and you have this checkbox. It's for every tool type, you can predefine what will be your toolpath color. So you can be more organized to this. And for this, you can define it also for milling tools. You can define it also for the turning tools, drilling tools, and also special tools that we have over here. OK, there are more features here, but let's go to another subject. I want to show you new things that we have built inside our MCO. And I'm going to do it with simple, as I don't have anything inside the setup. Let me just see if this is, yeah, all fine. So I will just add a machine control operation. So I have no job, I know, but I want just to perform a part transfer. As you can see, my part is in, let's say, cutoff preposition. And what I have here is already predefined MCO cycles. So let's use the pickoff cycle here. And what we have here, minimum necessary data input for our approach, yes? So if I click here on 15, and I want to do it like so, I go to my approach, movement, and I have Z4 approach. I hopefully, Y. let me try to do one more thing. So Mac, this is the workpiece. This is OK. This is Mac. Oh, yeah, I see. So I will go to my Mac 2. Let me just set up the sub spindle. So I will just open it here. I can see where is my, I'll hide my stock. And I'll mention where is my clamp position. So I will just leave it here on 15. This is how much it will be out from the collet. I'll save and exit. Let's try now this luck. I'll just select, do a pick position, go over here. Really? OK. So I wanted to show you how it works with the part pickoff, but seems that I'm not going to show this on this part. Really sorry for this. Let me go to the Milton application, probably because I don't have. I'll just click OK here. I apologize for that. So I have here a Milton part on which I have all my jobs defined. And what I have here is I will go to the setup. Let me show you this kinematic here. So I already have predefined here the main spindle and the setup for the main spindle. I see my sub spindle also here. I can also see where it will be in my clamp position. And I can go and say, here, exit. And what you can see here, I have my MCO that says here, go to the clamp position over the part. So let's open this very quickly. And here we have a rapid preposition. I'll just go and open a preview for you. So this is the state of the machine before the cutoff. And this is where it is located before the sub-spindle come with the rapid position and then go to the grab position. And what we have here is a simple movement of the machine that goes rapidly with the machine coordinates. As you can see, this is the machine coordinate move. And this is the value that you have here. So I just use my setup location as my equation, and I say plus 50. What you can see now is different is on the very right, you can see some dot here. This dot is nothing but a backflash of the sub-spindle here, and this is controlled point in the case when I want to do part positioning of the sub-spindle relative to part coordinates. So by far, we were only able to do it according to this point. Now what we can do, we have now an option. You go to the device, and over here, when you go from device, there is a couple of nice options that you can use, like fixture Z minimum, and it can read the back face position of any fixture that you have here. This is the same what I wanted to show in the previous example. And when you go to the movement, you can now see that point, it's over here. But now what is different? It is different that the mode, I can now switch to part mode, and now I can say, relative to this point, where is my part transfer position? So I go here, this is 10. So let's go to clamp position over here. I will do the same thing. I'll just use the fixture Z minimum. I go to the movement, go to the part mode, there you go. So extremely important feature, especially for the Kuma application, as they don't have like machine coordinate input. In that case, it's always relative to a part. This is the feature that you can use. Also, in this drop-down menu that you have here inside the device, you can use not only these two functions. You can make a non-cutting point on your fixture to any point on that. And in the drop-down menu, you will see also non-cutting point. So now you can do part transfer relative to part coordinates with any point on the fixture. OK. Next thing, I think it's a very small feature, but worth showing is that from to this version, we are also supporting opening and closing jaws inside the machine preview and also in machine simulation. So you can go to the closed jaws. You can see it now. It's the closed position, but of course, if you go to the open, you can see an open position. Very important, especially when you're doing the cutoff. Every millimeter here counts. So from now on, we can simulate it. Now, another feature that I want to show, these fixtures that we just loaded here, are now also visible inside any job, inside environment of the SolidWorks. So over here, always we had an option to visual a tool. So this is the feature that you can see. You can always see a tool. But now you can also see a fixture. So I can click on the fixture, and the fixture will be there as well. And this is for a milling application. That's OK. That's fine. And if you go to a turning application, this fixture is going to revolve, yes? So it looks now like so. All right. Let's go to, this was the live demonstration. And the next thing that I want to talk about is something that we start to support inside the post-processors, OK? I will not go in very technical depth about all of this, but I think it's very worth mentioning. In 2024, we introduced towards the configurations. Now, so what the configurations really are. Now, within the one VMID, within one interface, I can define and control multiple configurations very easily. So far, I always had to create like one VMID, another VMID, third VMID, and the problem was very simple. If I make any modifications to the first one, the same job I had to repeat to another and another if they are becoming to the same group of the machines. Any drilling cycle, any custom parameter, it was painful. Now, let's imagine that your customer approached you and say, yeah, you know, for this series, so especially like here, I put the Haas machine, but it doesn't have to be Haas machine. But if you have a customer who is saying, hey, I want on all of my Haas that we have the post, you know, please add this option. It was very like how effort you need to do, because for every of these configurations, you need to do manual work for every of these, yes? Configurations, what it enables that within the one interface, you can jump to any specific configuration or perform the change to among all configurations. So this is all about. Now, how everything looks, you can see it on the left side. This is the example where what possibility it allows. Yes, you can create 3 different machine simulations. Still, we are going to keep the VMID structure, yes, but the main idea is the master, the VMC file, will be the single file only. So in 2024 and 25, we still have the VMC together with other VMIDs, kind of merit to the VMC itself. But the idea for the future is that you have only one VMC and you are covering all machines in the specific group. The next thing is just here to show you the things that you can, yeah, one thing I forgot to say. Any of these configurations can be married to a single GPP file, yes? So it doesn't have to be different GPP files. You can also connect it with a single GPP file. Thank you. So this is how it looks roughly, where for anything that you do, for every, this is a classic menu when you do right-click on any item inside the VMID. So you'll get these these options over here. Even though it looks very simple, behind the scenes, it's very complex. But for a user, we just really did it very nicely. You can apply to specific configuration. You can add to all of configurations, remove it as well. Together, we have also save selection and load last saved. Very nice option. If you are working with, let's say, only 2 configurations all the time, and you don't want to make changes to others, click on those 2 configurations, save selection, and anytime when you perform any changes, it will easily, you just load the last saved. Very simple, very easy. Now, what we are solving is not only milling machines, but we can go and solve the cases like this one. This is a classic, I'll call it classic, from DN Solution, SMX series of 5100. And you can see how many configurations it has. So you can have it with lower turret, with subspindle, with Y-axis, with tailstock, without tailstock. So there's a lot of, there's extended version. What it allows us, it gives us power to create templates on a completely another level. So we can configure it, we can control it much easily than we were able to do by far. Another example, here is the, I give example of Star, their recent from SD26 series. For everyone who know this machine configuration, it comes with four configurations. That's the Type C, Type S, Type G, and E. I can see there are slight difference within, like with 2B axis, no, with some changes there with Y axis there on the sub. So it's different here and there, and with configurations, it's very easy to support it. We already did this machine, so you can see it on the left side how it looks. What is also good, these machines are coming always with guide bush and guide bushless version, so you can do it also. Now you can easily manipulate with these two configurations within the configurations as well, changing the axis, changing the limits, changing the machine simulation. Now it's more simpler within this VMC configuration. As I said, the guide bush or guide bushless also supported by the configurations. And I think besides configurations, this is, by my opinion, I know somebody is very excited when they see a new toolpath, new job, new tool, new feature here and there. But for me personally, this was a breakthrough in the post-processors. Even though it doesn't look like, oh, we support multi-languages. So what this means, actually, it is huge stuff. As you know, all of you are supporting your domestic language to support your customers locally. So many of the countries are using the English version of the post-processor, but if you want really to support your customer with local language, many of you are doing that, and that's very good. That's really good care. But where was the problem? So when Daniel sent the post-processor to any of you, this coming with the English version, yes? You make some adjustments and you change it to your local language. This is now two different VMID files. Any change that you perform, it's in your language. I cannot take this data and use it. So there was no really exchange of the post-processors. Like, yes, I can take it, I can, again, translate it, but it was a very hard work. This allows us to connect all post-processors worldwide to one database. There is no barrier of the languages now anymore. So what this practically means, so I go here on the very right of every post that will be a default, like will be in English. You can change your post. So if your post in German language, Spanish language, and etc., you go here and you say, OK, my default is Spanish, OK? Super. But the standard will be for sure in the future that first we are doing it in English for international stuff, of course, and then your local. Then we can exchange, and it is the same VMID. The ID is still the same. And I think this is great. For me personally, this means that now we can connect each other on a completely different level. This is a couple of pictures how everything looks like. Inside the VMID, it's fairly simple. You just switch the language. Nothing happens automatically. Here, I said that languages are not auto-translated. So you need to do this work for you. So anytime when you switch the language, there will be, of course, not everything automatically, but you can go and everything where you see like UI name, you can define for your own language. But in SolidCAM 2025, we already create automatic translator. So when you click on a language, on the very corner, you will see, I didn't put a picture of that, but you will see auto-translate. You click it, and he automatically translates to any of these languages that you see. Of course, some of the terms will not be 100% correct, but hey, it's not 100% of the things that you need to do, but instead you do only 20% of change because majority of the things he will translate it very nicely. So how it looks in the interface. This is it. Everywhere where you see machine parameters, MCO cycles, parameters in a job, everything will be translated. Very user-friendly from the first side. Yes, very important for our users, supporting it on a completely another level. But also, it's very good for us that we can exchange the posts on the level as we were never able before. And thank you for your attention.
Okay, the winner of the next pen is Milan Grigorievic. Nice of you.
Thank you.
Thank you. By the way, if anybody still did not get a bag, you can come now to that door and I will give you a bag.
Hello.
Hello.
Hello, everybody.
Hello, everybody. I'm together with my colleague.
Hello. And I'm together with Ahmad, and we have the pleasure to show you today the powerful solution we have in 5x simultaneous in SolidCAM.
Great. So, Wolfgang, I'll start, and then I'll hand over the stage to you. Thank you very much. So, today we are going to do two types of presentation. One, I'm going to present myself, my part in 5-axis, and Wolfgang is also going to present his part in 5-axis, where he's going to talk about this particular part on how he did it on NTX 500. So my presentation has got two parts. I'm going to explain to you why we need simultaneous 5-axis, why SolidCAM simultaneous 5-axis is needed. So first of all, we have got excellent toolpath strategies. We have got comprehensive collision avoidance system where we can take care of any kind of collisions that are coming, and we can remove those collisions and give a collision-free toolpath to the user. And sophisticated tool-axis control, because it's not a straightforward tool-axis control, it's a sophisticated tool-axis control. It's a proven technology. It's been around in SolidCAM for the last 2 decades, so it's a long, long time. And we have got excellent realistic machine simulation that simulates the entire part, including the material removal. So, when I say we have a comprehensive offering, we have got several things that constitute SolidCAM's 5-axis. The generic 5-axis, the multi-axis machining, which includes roughing and finishing, multi-blade machining, port machining, rotary machining, edge breaking, edge trimming, Auto 3+2 roughing, and finally, in 2024 SP2, we still have it in the beta, but you can use it because it's very, very robust and reliable. We have as the 5-axis milling of Pro 3D HSM. It's still called as Turbo, but we'll soon have the name change of this particular technology. I'm going to run quickly through the first few slides, primarily because I've covered this in several of my webinars and everybody knows about it. But I'm going to talk to you about a very important project that we did with Kennametal. And it was one of the most important projects even in my career that I did, because a lot of things I learned from that project. And I'm going to present to you that particular technology. It's kind of a technological cooperation. So I'm going to run quickly with a generic 5-axis. It's a perfect solution for any 5-axis machining. You can machine the part the way you like it. You also features user-defined collision check, smooth lead in and lead out for all standard tools, including the circle end mills. And then we go on to the rotary finishing, which is meant for finishing of cylindrical parts. You can directly calculate the tool path on a 3D model. Along and around strategies are available. tool contact point can easily be modified. Swarf machining, very robust engine for machining walls, basically prismatic parts in 4, 5, and 3 axis. Clean results, most of the time they are burr-free results. Automatic tilt control, and it has got a very high demand. Any company in the world will always need swarf machining as far as 5-axis is concerned. So, moving on next, the 3 to 5-axis conversion. This is more for die and mold components or areas which are very hard to reach. You generate a 3-axis toolpath, and it automatically tilts the tool to give you a 5-axis output, allowing you to use very short tools to go deep into a particular region. Because of the short tool nature, we get excellent surface quality, and there's a reduced risk of tool breakage. Multi-axis drilling, again for drilling from different directions, automatically you can create the drilling paths in full 5-axis. Tilting, linking, and collision avoidance are already built into the drilling system. The drill depth is automatically controlled by the software, and it's a very powerful tool to improve your efficiency and productivity. And there is no special expertise needed. The training time is bare minimum. Contour 5-axis machine, this is for deburring of the edges, and it's more of a manual process where no surface definitions are needed. It's a very robust engine. Tool orientation is done by tilt lines. It supports different types of tools, ball, bull, end mill, chamfers, anything. Geodesic machining, it's a new generation pattern generator. Basically, it's just a pattern generator. It doesn't do anything with the tool axis and all. We still use the same tool axis control of our generic 5-axis. And the step over that is generated is constant, irrespective of from which direction you look at it. And it works both on the mesh data as well as surface groups. Auto 3+2 roughing creates automatic 3+2 roughing programs from different directions, and can be done in automatic, manual, as well as semi-automatic way. Circle end mill support. We are supporting barrel tools since 2019. More and more tool manufacturers today are producing these tools, pushing them into the market, and claiming that they save up to 90% of the time as far as machining time is concerned. And that's primarily because of their large radius, big step over, still allowing you to get the same scallop. So we support all the 4 shapes that are shown. Multi-axis machining, again, this comprises of 2 things, the roughing as well as finishing of pocket-shaped geometries in 5-axis. It's very simple to work with. You just have to specify the floor and the wall, and the tool paths are generated automatically. Adaptive roughing feature is also available, which looks very similar to eye machining. The wall and floor finishing utilize the new generation circle end mills, which is the barrel, oval, taper, and the lens form. Okay, that's about the wall finishing. Just talked about it. Moving on to multi-blade machining. This is for impellers, where it's a very powerful machine. It's a machining engine for impellers and blisks. It's a classic impeller with splitters. That's a classic application. Minimum inputs, automatic tool axis control. Root fillets are handled with ease, and more often it generates a tool path very quickly. And there are separate machining strategies for roughing, blade finishing, floor finishing, and fillet finishing. Port, again, for tube-shaped geometries. This is, again, a machining engine for tube-shaped geometries. Like multi-blade minimum inputs, very powerful automatic tool axis control. Roughing, rest roughing, spiral finishing, and plunge finishing strategies are available. Rotary machining, this is again for cylindrical components where you can do roughing as well as finishing when it's rotating around the 4th axis. It's a very powerful functionality. The roughing is based on Pro 3D HSM. Only thing, the difference between Pro 3D HSM and rotary is that in Pro 3D HSM, the slicing is done using planes, while in rotary, the slicing is done using cylindrical space. So we support all the standard tools, and the user just selects the part, stock, depth of cut, side step. Everything else is done by the software. Edge braking, I've talked a lot about this. This is one particular module that every shop floor in the world will need it. irrespective of what kind of part they're doing. Edge braking is something that everybody needs. So it's an automatic functionality that generates deburring toolpath in 3-axis, 4-axis, 4+1, 5 minimum tilting, and 5 full axis. And currently, this is a very manual process. A lot of people are employed for it. And the edge braking now, the automatic edge braking removes all that particular manual edge braking or manual deburring that is done and brings the mathematical deburring directly on the machine. Edge trimming, it's for trimming of vacuum form parts or composites. It's a very highly automated algorithm for composites and other components. The trimming edge can be automatically defined, and the position is relative to the geometry, and there are various options to define the position of the tool. I'll come to Turbo 5-axis. I'll spend some time on this because this is something new that we released in 2024 SP2, but like I said, it's still in beta because I want more and more people to use it and come back with me with issues. This is it's Pro 3D HSM, and the generation happens in 5-axis. So you have got constant Z rest machining, you have got linear machining, constant step over machining, rest machining, all of these functionalities working in the 5-axis space. So generation itself directly happens in 5-axis. So it's a proven engine. It works on the Pro 3D HSM engine, and simultaneous 5-axis toolpath controls options are just added, and that's more or less an automatic option of tilting the tool. It's completely automated. There is nothing that the user really needs to do. Of course, there is some tweaks that the user is allowed to do. It's an excellent solution for machining molds and dies. Okay, you can try this. We have added another functionality to this Turbo 5-axis, and it is available in the undercut machining. It's called as 5-axis undercut milling, wherein you can use that particular functionality to machine any component. It doesn't matter if it's a die mold component or an aerospace component or a medical component. All the tilting and everything is done automatically by the software. You don't need to define what it needs to do. So it's a very, very powerful functionality. So it's a combination of two functionalities. Shortest learning curve, hardly a few hours of training, and you're up and running on the job. And it's a very robust and reliable engine. So I did some research using some AI functions because I hate to use Google these days. So I used AI to ask what is happening, what is the chatter that is going around on the internet about good and bad things about SolidCAM. So I brought some good things about SolidCAM, and I want to show you that. First of all, people are talking about the ease of use and flexibility of the product, especially in 5-axis. So they are talking a lot. There's a lot of chatter about this particular functionality. We have advanced toolpath control. A lot of our competitors' users are speaking about this. Okay, most of them are using our most commonly used softwares. We have a very good collision avoidance systems. This has come mainly from the Autodesk users. This is what the AI system told me. And we have very strong simulation capabilities. Again, this is coming from our competition, not that I have written it. Okay, in the summary, we have a very complete, powerful solution to machine any part. It's the most tested and proven 4-axis, 5-axis engine. Easy to learn with a very user-friendly GUI. Complete control on the entire toolpath aspect. Complete control over toolpath collision avoidance system. And application-specific strategies, including edge deburring, Turbo 5-axis. They all complete the offerings that we have. So overall, we have a very powerful product. Now, this is what I am telling you. If I go and tell my customer this, that I have a very powerful product, he's not going to believe me unless and until he doesn't see this happening on his own part and own machine. So what we did was there was some kind of a initiative taken up by Kennametal. And Kennametal wanted to work with us to find out a solution or a replacement for their existing strategy in which they use Siemens NX and their tools and their process to machine an IBR. An IBR is nothing but an integral blade rotor. Okay? Now I'll come and tell you what this integral blade rotor is. So what's an integral blade rotor? I mean, everybody would have flown into Munich. So when you look out of your engines, you see the big engine, and you see, first of all, some discs outside. So that's the first integral blade rotor that you see outside on your engine, on that part. Now, there are many such rotors within the engine. I counted about at least 18 rotors within that engine. Okay, so it's also known as a blisk or a bladed disc, and it's a very critical part in the turbo machinery, particularly in the gas turbine engines. It's characterized by integration of the blade and the rotor. So everything is one, fused into one. No longer it is an element that is separate. And this design eliminates the need for having a separate removable blade, which actually reduces the efficiency of the engine itself. That's why this integration happens. And it's typically manufactured from high-strength super alloys, and it's machined using 5-axis. So that's the typical engine. Like I said, I counted there are about 18 different IBRs on this particular engine itself. Depending on the size, it could be more or less. So the industrial application, first, they are used in aerospace industries by both military as well as commercial airlines. Power generation, it's there also in marine propulsion, and it's there also in industrial turbo machinery like pumps and compressors. So, it's a very big market, okay? And the estimated size of this market of machining this particular integral blade rotor is approximately $19.6 billion in 2022, and it is going to touch about $30 billion in 2025. I think it's 2030, sorry. And it's growing at the rate of almost at 9% with the kind of aircrafts. If anybody is having internet, just open flightradar24.com and look at the map of the world, and you'll see thousands of aircrafts flying at any given time. So all of them use the IBRs. So who is the four main players in machining of this particular IBRs? First one, Siemens NX. Second one, Dassault CATIA. Everybody will be thinking, why CATIA? CATIA is being used. Let's accept it. The third one, which is also very popular, is NREC MaxPack, which is a very dedicated solution for turbo machinery. And the fourth one is OpenMind Hypermill. So these are four players that are eating away this $19.6 billion pie that is there in the IBR market. Where is SolidCAM? Nowhere. We're not there in this market. Okay? This is a huge market. Huge, huge. Beyond our imagination. It's a huge market. And products like Hypermill and NREC MaxPack, they have niche products just for this particular application. Okay? We are still not there. But machining an IBR is not a straightforward thing. It's not that you just create a toolpath, you go on the machine, it runs, it will not run. There are several challenges. Complex geometries, material is hard, deflection during machining because each IBR is not more than a millimeter or millimeter and a half thick, so there's a deflection. Cost implications, it's very high. Each IBR costs anywhere between $30,000 to $40,000, so a slight mistake can scrap the entire IBR because it's an integral one. It's not it's not those blades that are assembled. Furthermore, there is surface roughness. That means you need to have a very smooth surface. That's another challenge. Waviness and deflection, tool wear and material removal, and surface integrity issues. These are all the challenges that are there in the IBR machining. So, what we learned from Kennametal. I still remember, quickly I'll give you in next 20 seconds. We had a meeting with Kennametal with Avishai. Where are you, Avishai? There he is. So we had a meeting with Avishai, we had a meeting with one of their chief technologists, Yossi, who sits in Israel, and their NX programmer, and they were explaining to me how an IBR is to be machined. And they were trying to find out whether it can be done in SolidCAM. So I had two screens. On one screen, I was listening to them and looking at them. On the second screen, I opened a very similar looking part like what they were showing me, and I started programming them as they were telling me the process. So when the meeting was over, they asked me, did you understand the process? I said, can I show you my screen? And I showed them that in the time they explained me the process, I had already created that process on SolidCAM. It's that easy to work with SolidCAM in 5-axis. Although it looks huge, but it's very simple to work with SolidCAM in 5-axis, okay? So, like I said, Kennametal has already done this process. They have finalized, fixed this process both with NX and CATIA. And they had issues with both of them, working with them. Although it's working, but there are challenges. Constructing an entire geometry in NX and CATIA is not an easy job. They need to do that. Tool-axis control in multi-axis operations is very, very difficult in NX and CATIA. And there is limited multi-axis strategies both in NX and CATIA. And then the user interface challenge comes up, and limited collision checking capabilities. So, with SolidCAM, what we did, I don't want to run this because this is the same slide that I showed you before, but I would like to show you what we did with Kennametal and what makes SolidCAM special. Consistent tool engagement, this is what we found on the entire part. Minimize toolpath deviations. Backplotting for visual SimCoke turns out to be a great savior here. With the new version, you can do the material cutting simulation, and there is enhanced simulation capabilities. Actually, I'm going to do a webinar on this when I get back because it's a very vast subject. We spent months together on this particular area here. So if you look at the part that we did it on a titanium 6 ALV. It's a titanium alloy. The machine was a DMU 65 monoblock, number of blades 55. The blade height was 60 mm. The thickness of the blade 1.5 millimeter with the end radius of 0.2 millimeter. And the diameter of the IBR was 778 mm. We just took a portion of that to machine it. And this is the blade, 60 mm. With, if I zoom in further, it's about 1.9 millimeter at the thickest section of the blade and 0.2 millimeter fillet at the end. So it's a very complex one, and this is how we did this process. Was supplied to me by Kennametal. So we started with the single slot roughing, and then we moved on to semi-finishing the aerofoil. On the very first level, we did not go all the way down. We just went level by level. We did the roughing, semi-finishing, and finishing. Okay, so we used all these methods to machine this entire part. So that's all the 3 levels in one go. Okay, and that's the cutting time for each of these levels. So what, in the end, we noticed, Wolfgang, I'll just take one more minute and I'm done. What we noticed in the end of this entire exercise was the strategies that use ball nose are far more efficient than the strategies that use barrel mills. Because all of their competitors were using barrel mills to machine it, and barrel mill actually slows down the machining of such parts. Like I've always believed that barrel mill is not a tool that can be used anywhere. It also has its own limitations. Okay? So in this particular case, because the barrel mill has got a very large surface area when it comes in contact with the blade, it can deflect the blade when it is machining. So it's not something that can be used on this particular part. And here the ball nose becomes very, very important. So like I said, I'm going to make a complete webinar on this entire subject of IBRs. It's a very vast one. In fact, I've tried to compress what we did as a solution with Kennametal into few slides. So the summary is, we have very good toolpath strategies for IBR. We have excellent collision avoidance, realistic machine simulation, robust and reliable post-processors. We were going on the machine on the very first attempt, no changes on the G-code. And finally, with the SimCoke integration, like I said, is a savior for us. we can do material simulation and comparison of the part once the part is done. Right, I'm going to hand over the stage to Wolfgang. Wolfgang, sorry. Here.
Thank you very much,
Thank you.
Ahmad. Okay. Thank you for the deep insights in the IBR machining and the cooperation with Cannabital. I want to talk about a little bit about SolidCAM.
One second.
Yeah.
Okay, I'd just like to thank Ahmad for the nice presentation. I would like to tell everybody in the room from the different country, I committed that if you have any customer produce IBR or any kind of airfoil milling against any kind of software 5-axis, that any project that exists, I commit at least to reduce cycle time with SolidCAM at least 25 to 30%, and it's in this case is hours, is days of saving. If one of you have any opportunity, contact with Ahmad and we can join together and go into the project.
Okay, now it's my turn. I think I have a little bit to hurry because I only have 5 minutes left. But what I want to tell you, why SolidCAM offers one of the best 5-axis simultaneous solution in the whole CAM market. I come to the conclusion there are 5 major topics why we are the best. First, Emil also mentioned it, we are fully and seamlessly integrated in the CAD system. Not only one, it's 4 at the moment and getting more and more. The second point, we have powerful strategies and an easy to use interface. The third one is the technical stuff we have at SolidCAM. We have highly skilled employees with practical background who can offer solutions to the customer. Fourth thing, post-processors. One major advantage is all post-processors on machine simulations are done by ourselves, and we are very flexible and can quickly create posts for any kind of machines. And the fifth one, we have excellent partnerships with the whole industry, with the strongest technology partners in the industry. Okay, now I want to talk about why I think this is a major advantage with the CAD system. We have a fully grown CAD system in the background. You know, when you mill some parts, you always have issues. You don't have perfect parts you want to mill. And with a CAD system in the background, it's really easy to use to fix things, to patch up surfaces, patch up holes in a couple of clicks. I think that's a very, very big advantage. And it's easy in SolidWorks, it's easy in Inventor, it's easy in Solid Edge. In all our CAD systems, we are seamlessly integrated. Powerful strategies and easy to use interface. When I begin at SolidCAM, we only have 3 solutions for 5x simultaneous. That was HSM to 5x conversion, multi-axis drilling, and 5x generic simultaneous. Now with the SolidCAM 2024, we have over 15 strategies for any kind of parts, and I think we can machine any part we want. Okay, what's also easy to use the interface. When you program with SolidCAM, there are always 3 steps you have to take to get a toolpath. First, define your toolpath, define your geometry. Second, you have to define your tool. And third one is set up your parameters. It's always the same. It doesn't matter which shop do you use in SolidCAM, you always have to define these 3 steps. For the complexity of the 5x simultaneous as it is, you have to do two additional steps. One is define your tilting, how you want to engage your part or approach your part. And the last thing is collision checking. But with the example of geodesic operation, you can do in a couple of clicks 5x simultaneous, collision-free toolpath. You can run on the machine without any to get in any trouble. Okay, last one, collision control. I always take the automatic tilting. It's perfect. Okay, one major advantage I also want to mention is we have highly skilled technical staff. Nobody was born as an expert. Look at me at a young age. I didn't know how to properly use shoe cream. But with training, experience, thirst of knowledge, dedication, trying, and also failure or mistakes, you grow to an expert. And that I can say to any technical staff, to any employee in SolidCAM, they are all experts. I know we have the 40-year anniversary for SolidCAM, but in my opinion, the knowledge from the SolidCAM employees is far more than 40 years of experience. Okay, fourth thing, it's also, SolidCAM has the best technical staff in the market, and with that knowledge, we can have a solution for every customer. So, next thing, post-processor. Post-processor is a main advantage because it's done by ourselves. We don't have to go to a third party like other CAM systems, and that makes us very flexible. We also have very high qualified post-processor guys. Look, the guys in Serbia are perfect at that, what they're doing, and they can manage any kind of CNC controller. For example, we set up the AMB machine. It was a CTX 450. It's the serial number 2. It was a prototype machine. Ronnie sent me a post, and it works. Works first time. Okay. Excellent partnerships with the best technology partners in the industry. I think it speaks for itself. Everybody wants to cooperate with SolidCAM. Also, Michael mentioned it, in his lecture, and I think take these partnerships, find a solution for your customer. It's a game changer. If you have a complete solution for the customer, use it. Yeah. One thing I try to hurry up a little bit is the part Michael always mentioned. It shows us what we can achieve with such a strong software and such a good cooperation. The Lada Manufaktur is a company in the north of Germany. They do power enhancing and car tuning parts. And they come up to us and ask us if we can help them to mill a complicated part. This was the part they want to mill, and they want to do it from a full aluminum body. Yeah. Okay. This part is for a car of a German car tuner. It's called JP Performance. He's a very famous car tuner, and he wants to build up this Volkswagen Golf 2 with 1,000 horsepower. JP Performance is very influential in the social media. He has 2.6 million followers on YouTube, almost the same on Instagram, and this is a big marketing for us. So, Michael found this part so excited. He talked to me and said, hey, can we do it on the AB exhibition to 2024 on a CTX 450 TC? It's a mill turn machine, and 80% of this part are milling operations. Yeah, that's the part. And we did it on this kind of machine. As I mentioned, it was the second serial number 2 of this machine. It was a prototype. It was a world premiere. We had this machine on our booth. And the people liked it very much. We started with a stock material of 15 kilograms, and this around about 1.5 kilograms was left from the part. That was the first step. But for the Thunder Bunny, we need something more special. And Michael came with the idea to mill this part. This is the original version they put in the Thunder Bunny and show it on the SEMA in Las Vegas. It's a big car show in November. Yeah, I also have a little bit of video, but I think it doesn't work. Yeah, it's a little bit round up how I milled the whole part in Alzmetall. It was a very beautiful part because we have every kind of operation in this part. It took me around about 6 hours to mill the whole part, and yeah, the part in the end was perfect. Yeah, I skipped it. Okay, and also on the AMB, we give them to the Lademanufaktur. This is the final part. This is the final product. They build up in the car. They also will be gold coated. And as I told you, in Las Vegas, you can see this car with our milled turbocharger housings. And this last phrase I like very much. Everyone knew it was impossible until a fool who didn't know came along and did it. And I think with our solution, we can handle everything. That's for me. Thanks for your attention. Thank you.
Okay, a few words about our 5-axis. There's no doubt that Hypermill have done more marketing than us. So we should do much more marketing and branding to explain our strength of our 5-axis, which, as we see, is really strong. And we are going to enhance it even further. We have several projects for that. You have seen Avishai Zohar here, the guy who talked. Avishai Zohar used to be a major manager in Kennametal. He left Kennametal I think about 8 months ago, and since that time he is our paid consultant. So he's working with us as our consultant. He was involved in our Titan relationship. He's involved in our relationship with Kennametal, with ISCAR, and also with this IBR project. So he might be in touch with you on some projects, so you know that he's working for us as a consultant.
By the way, good news, we have more bags. So in the coffee break, please, again, come to this door, and I will give bags to whoever did not get them. Thanks.
Thank you, Linda. All right, SolidCAM for operators. Let's teach you guys and let's show you guys how great this little tiny piece of software is a game changer for any customer out there, not just your large machine shops. Whoop, let me go back here. So our main goal with SolidCAM for operators is there's a big disconnection, especially in a large machine shop where you got the manufacturing, they're doing all the programming up here, and down on the shop floor, they're doing all the machining, right? There's a lot of disconnection. We send setup sheets. We do everything to help them out, but they still don't get a good grasp of what's going on. So this is solely built just for that reason, bridging that gap. No longer do we have to go up to the programmer's office to get program changes now. Don't have to, at least my old company, it was a half-mile walk just to get up to the programming office. So this eliminates every single CNC machine. Let's be honest, they all have computers. Computers are cheap. We can run SolidCAM for operators on these smaller computers that are sitting right next to the machine. And a great example of this was at IMTS, we had Omega in our booth. And Omega had their tool presetter, everything looking great, but what I had them do is I had them add a second monitor on there, and they had SolidCAM for operators right there. So while they're measuring their tools, they have all the data right at their fingertips as they're getting their tools calibrated and everything's good to go. It's actually so good. When we were at IMTS, it was so busy. We had 6 demo stations completely full. We had lines waiting for it to get demos. So I actually did a demo on the Omega machine with SolidCAM for operators showing off the software. So that's how powerful this stuff is. It looks like a little program, but it's got the huge impact right there for you guys. So in a typical shop, we see a ratio of where are we going to need SolidCAM for operators. Now, if you're 1 to 3 CNC machines, yeah, you might need it. But, I was just at a shop doing our iMachining Road Tour. He has 4 machines in his shop, pretty small shop, but when he started, he only had 1. Every computer he had his setup sheets pulled up on. Just a cheap little laptop for his guys to have a setup sheet there. And I told him, it's like, instead of having a setup sheet, why not have the entire simulation so the guys can see it? I mean, we're, as machinists, for those of you that are here, when it gets close to that clearance plane, ooh, boy, that butt puckers up real tight. We don't have to worry about that anymore because we can play it through right here and there. So, what is this going to do for you guys? A very clear picture of setup prove out. Eliminate setup time, no dry cutting, no air cutting, no testing out programs. We can run it through the entire simulation right here, know that it's good, and then we should be able to run it on the machine, walk away, and not have to worry about anything. Minor changes, and as let's say I bring on a new machinist. Yeah, he doesn't know very much. Well, I can limit him out so he can only just view everything that's going on in there. So the operator that's at the machine, he's not having to decipher all this G code. He has full graphic simulation to be able to see what's going on there, along with crash detection. So with our 3 different levels, these are big. So the simulator, I'm going to start off with first. Our simulator is basically for your general machinist that does not have a lot of knowledge. I don't want them changing my feeds. I don't want them changing my RPM. I don't want them modifying my geometry. Everything is kind of locked down, but he still has full visibility of what he can do. Well, here, we'll go through them. So, editor 1, got a little mixed up there. So, editor is the top module. This is the module where I can modify my geometry, I can modify my feeds and speeds, I can change tools out. As I'm listening to that machine, we talked about we're leaning on the machine to feel the vibrations and make sure that's cutting. And boy, if I change that from a 3/8 to a 1/4 inch, I bet it's going to sound better. I can do that right here without having to go and reprogram the entire part, going back up to the programmer's office to get that done. I have full capabilities of editor 1, okay? Now, we have editor light. This is for your machinists that are starting to get a little bit more curious. So now they can change toolkit, but they can only view part setup. You still get full simulation, full G code, as well as view all the operations. And then is basically our starter, I would like to say. We cannot edit anything. We can't edit the toolpath. We cannot edit feeds. We cannot edit speeds, step downs, any of that stuff. It's basically locked out. It is basically an amazing simulator, right? Now, the great thing with this is, like I said, computers, cheap computers are easy to find nowadays, right? Well, at least in the States, a lot of machines have a computer right next to the machine, and we can have this pulling up while they're running that machine, which is really great. And like I said, the guys at, boy, I can't think of the name of it, but they're up in North Dakota. You guys will see it on the iMachining Road Tour when I go to their shop. Every single machine had their computer, their G-code, and a setup sheet. Let's eliminate that setup sheet and let's give them full simulation. Let's give them the full visibility of what they're able to see. Let's eliminate, if we start thinking high-end production. Now, I'm going to talk in inches here because that's the only thing I know. But clearance plane, by default, we'll throw at, half inch to 100 thou. Now, if we're doing high-end production, that tool is going to wrap it down right to 100 thou above the part. It gets a little dicey when you're setting up. But now, once I get that tuned in and everything's good, I can modify that clearance plane down to 10 thou because I know it's good right on the machine. I don't have to go back up to that programmer and bug him because he's grumpy and he's up in the office drinking coffee, right? So, major benefits. Preventing machine damage is huge. Like I said, tech guy, I don't know what this stuff costs, but I know a spindle is way more expensive than what SolidCAM for operators can offer for you. Efficiency, like I said, when Daniel Santos was up here talking about the scheduler, that machine, when he clicks on it to have to go back up to the operator to reprogram, well, that machine's sitting dead, right? So another great advantage of what's going on here. You get a full simulation package, full machine sim, everything at your fingertips. I'm running on a tablet, right? So a lot of you Germans here, after Oktoberfest here, I have to go to the farm and go help my brother-in-law go farm. I have customers, tablet never leaves my side. I have customers that will send me part files, and like Linda said, out deer hunting, I'm waiting for the deer to come, and John from Tecomet calls up and says, hey, can you look over this program? Sure. I'm on a tablet, running Swiss, on a sprayer nozzle right now, on a tablet. That is impressive. So, like I said, we're eliminating more time. We're getting it so long, when that machine is not turning, we're not making any money. So we're eliminating the dry runs. We're eliminating all these prove-out stuff. We have all of our controls right at our fingertips. And like Emil said, a lot of these new CNC machines are coming with PC-based controls. We can throw SolidCAM for operator right there, so we can play it through on our controller, boom, flip over to our program, cycle start, we're rocking. Can you tell I'm excited for it? So, great tool for any machine shop. And, Emil's slide couple before, larger machine shops need more seats. But in my eyes, even if I'm a one-man band, unless I have my programming computer right next to my machine, I would get SolidCAM for operators because by the time I'm dicking around with my machine here, my fingers are all dirty. I'm not going to go touch my fancy, expensive computer to reprogram it. I can go to my tablet, boom, boom, quick change, we're done. And like I said, we bridge the gap. Smaller shops, they're closer together, but like at the machine shop that I worked at, we had 100 CNC machines, and it's a half-mile walk just to get up to the programming office. Waste of time. If you think about it, in a machine shop, when the operator has to leave that machine and walk any distance, does that operator ever just walk right there, or does he get distracted by talking to somebody, or look at this part over here, or look at this part? We're eliminating all that downtime for you guys. And here is a little video. And I want you guys, this is on SolidCAM University. There's no word, I'm not talking in here, but it's a great representation of how SolidCAM for operators can really help your shop out. Well, and then we got the operator, the programmer. Nah, I'm not touching his program. No way. So then you got to get to the other operator. Now I've modified my program. All I had to do is add a small little offset for my pinhole. The big boss man, what are we waiting for, guys? Come on, let's get going. Happy operator.
Okay, so really every one of your customers needs SolidCAM for operator. I've heard, for example, from Solfins, our reseller in Serbia, from the manager Serjan Zivkov, that one of their biggest customers, they have more seats of SolidCAM for operators than SolidCAM for programmers. And I'm sure they are happy. Okay, so now you're going to hear something for the first time in the SolidCAM world. Something unbelievable. Some people know about it, very few. We are launching SolidCAM for salespeople. Any clapping? SolidCAM for salespeople. It's very simple. SolidCAM for operator can be used by every salesperson. Why? Ashok Kumar from SolidCAM India has prepared a complete list of CAM parts with machine simulations. So, as a salesman, you have to do nothing, but you have a tablet with SolidCAM for operator, load a part, and show a beautiful machine simulation. You could load a part mill turn, load a part of 5-axis. You can show really the power of SolidCAM using SolidCAM for operator. So now, it's a must. Every one of you salespeople of SolidCAM should have SolidCAM for operator on his computer, whether it's a notepad, regular computer, and Ashok Kumar will provide you with beautiful parts, and you can use it whenever you want to show, very simply, the power of SolidCAM. If you are at the customer, or even if you are online. Never again be without SolidCAM for operator. It's your tool to show the power of SolidCAM. Enjoy.
So with the Olympics, I thought it'd be pretty cool to make myself some titanium shoe spikes. Now, while I was dialing in this process, I really found out how easy things like this are really getting. So when we were filming this, we actually ran the titanium dry, which is kind of stupid, but we ran the titanium dry, and my insert actually broke on me on my face-off. Sparks went flying everywhere. And immediately after that face-off, I turned on my ACB technology, and even with a broken insert, it still flaked the chips out like it was nothing, which is insane, right? But how's that possible? Because any of you machinists out there know, if you have a chipped out insert and you try to turn titanium, well, it's not gonna go very well. So the reason why this is possible and the reason why it works so well is because when you're turning conventionally, you're progressing through the material in a linear fashion. So your spindle's spinning and your tool's just moving forward like this. But with the ACB technology, that's not really what's going on. It's actually creating air pockets. See, what's happening is as the spindle's spinning, the tool is staying in sync with the clocking of the spindle and making a waveform pattern that creates air pockets every other revolution. So when you actually look at our slow motion footage, you can see it. You can see it slightly backing off and the chips flaking off. And that's why, even with a broken insert, it still breaks the chip perfectly, which is crazy. And you can see this on our drilling, our grooving, and our turning on this process. So I was able to actually run titanium dry without any fear on a Swiss machine. Well, there was some fear when the insert broke and sparks went flying everywhere. I'll be honest, yeah, there was fear. But next thing I want to talk about is how easy it was for me to program this. And instead of sitting here and telling you how great SolidCAM is, let's go over to my computer. I want to show you how good SolidCAM really is, and I want to show you how easy programming a multi-channel Swiss machine really can be. So enough talk, let's go and check it out. Okay, so as you can see here, we have our part open in SolidWorks, but I want to show you how easy it is to program this in SolidCAM from the beginning. So we're gonna kind of speed run this in a way. New, mill turn. We're gonna save it as a PRZ file. That's just kind of what you always do. And now SolidCAM's gonna do some thinking. Now we have the choice to pick our machine. I'll go to DT26. We'll click coordinate system. I always click a revolution service on the outside of the part. That'll always make the work coordinates in the center of the part. But I can see here it put on the wrong side of the part. So I just hit change to opposite and that puts it on the right side of the part. Now I just hit okay. Now SolidCAM's gonna do a little bit more thinking. It's gonna create a work coordinate already on the back of the part for me for my subtools. So now we're done with that. The part's in there. All we need to do is bring tools in, and that is also really, really easy. So over here on the left, I can import tools from previous CAD files, which is what I'm going to do. SolidCAM, we'll go to projects, shoe spike, and this is the old one I did. This will just make it really easy for me. I can just bring in all my tools. So I will just drag and drop these into the right positions from my old file. And you can do this with any file, right? It doesn't have to be like the same file I'm doing. It can be another part that you have similar tools on. Instead of rebuilding the same machine over and over and over, you can just grab your old tools. It's really, really nice actually. So first thing we do is we face off just like any other Swiss part. Geometry, we'll select geometry. I will go to chain, click on that guy right there. We will say okay. Yep, it's okay to accept. That is our geometry. Data, speeds and feeds. I'm just gonna stick to 200 surface foot for all these. I'm not gonna get crazy with it. Tab. And for my feed rate, whatever, 2,000 per rev, that's fine. So now if I click on this and I select V, I can go into simulate. And what's cool is you have a whole bunch of different ways to look at this, but when I'm doing basic turning operations, I just keep it simple with the 2D turning one. Take a look over here, single step it, and just like that, we're facing off. Cool. So that's our first toolpath. So on to our second toolpath. We're gonna rough and finish turn this part. Just gonna go to turning, go to geometry, select the radius on the front. That's where I wanna start. Already knows the direction I wanna go. So we'll select here, and we'll say okay. Now we will go to modify geometry. We will extend to the end of the part by clicking this point right here at the end, 178, but I want to clear from my grooving tool that we're going to do later, which is 62 thou. If you add those together, you get 0.240. We'll go to tools, we'll select our turning tool again. Technology, we're going to finish only. We're going to semi-finish and finish. So I'm going to do ISO turning method, and I'm going to leave 10 thou in X and 3 thou in Z. And yeah, I'm just gonna do one pass and see what this looks like. Select my part, press V. I just want one pass and then a finish pass. So that is exactly what I want. So for our third operation, we are going to drop down with an end mill and put this flat on the part. It's pretty simple. So in SolidCAM 2.5D, we'll go over to Profile. For geometry, we need to select our other machining position. So you look right here, we have our second position on Mac 1. That's a work plane I created for the milling, points up in X. So I will select my geometry now, go to chain list. Now I will turn off tangent propagation and constant Z face because all I want to do is grab this line right here. I don't want it to do any thinking for me and try to loop around and grab anything. So I have my chain selected. I will say that is okay. For tool, select, drop down, end mill. I'm just going to change this to tangent, tangent, So I'm not going to worry too much about speeds and feeds. I really just want to show you how easy the software is to use and select toolpaths and get everything going. It really is really convenient. So let's select this, let's simulate it. Let's go to machine simulation. So as you can see here, we are now in our DT26, our end mill's coming up. Step forward, drops down, mills are flat. It's beautiful, but I'm only milling one flat and we need two flats. So let's get out of this. Let's go into our contour. And right here, we can do transformation. We'll do 4-axis, we'll do angle, 180, include original operation, and we will say insert. And just like that, now you'll be milling two flats. Pretty simple if you ask me. So now I'll press V, I'll go into simulation, we'll go into machine simulation. It's gonna drop down and mill the other flat. So there you go, you got two flats now. So all we have to do now is groove behind this head here and then do the single point threading. All right, so next we're gonna hop into our groove tool. Now I drew some geometry right here because the way grooving works in most CAM software is you need geometry in the left and right to create a groove. You can't just use a little profile. So I drew that. Now we're just gonna go into grooving. We will select our geometry. I will say go from right here to right here. That chain right there should do just fine. Tool, we will select our tool. Just our groove tool should be tool 132. So rough, we are going to say step down constant. I think I'm just gonna do single. That should be fine. There's no need to peck. If offset in X, we'll say 10 thou. Distance in Z, I usually leave like 2. Yeah, that should be fine. Semi-finish, ISO turning method, rest material only. I'll just make it do the entire geometry. It doesn't need to look for anything special. Links from right safety corner. Honestly, that's good for this. Let's see what it does. All right, so we will press V. We will go to simulate. I'll just go into turning. Let's single step it. Okay, groove tool comes in like that. Rough plunges everything out and then swipes across. That should work just fine. Now on to threading. We'll click threading. Modify geometry. I will actually go in and modify this because I know if I start my threading tool right here, it will wipe out material right there. So we are going to go to, minus 14 thou. No, let's do like minus 0.025. End extension trimming. Let's extend it to the end of the part, so it's an additional 25. I'll make it 30 just to make it so it goes all the way through for sure. Tool, select, external threading. We'll do 32 threads per inch because that is a 1232 thread. Depth, it should be 0.027 thou, I believe is how deep that thread is. Step down, 5 thou. Minimum step down, let's do 3 thou for our minimum step down. Our normal step down, we'll do 7. Link from right safety corner. I think that all should be good. There we go. So yeah, now you can see the threading tool is going far enough, so that's good right there. All right, so now that I've got my turning, milling, and threading all done on my part, it is time to do the transfer, and this is where SolidCAM really shines because I only had to figure out one transfer in my DT26. And I can actually go over here, and you'll see right here in this folder, DT26 transfer. I have all these different MCOs that I already figured out. And I could go through all that, but I just want to show you, once you go through one part, you can just do things like this. Just drag and drop into your tree, use machine coordinate 1, and just like that, I just fed my part out, positioned my cutoff, came up with my sub-spindle, grabbed the part, and did the cutoff. You're gonna see that fully in a second. I select all of these, press the letter V, and go to my machine simulation. I can take a look and just make sure it looks right. And we have 2 views up right now. We will utilize that in a second, you will see. We will run it. Just make sure it comes over. Counter spindle goes up, grabs the part, cuts off. Looking good to me. Let's go and finish this part. So what we need to do now is just drill the back end and then deburr it with our boring bar. And then after that, we're pretty much done. Let's go to drilling. Let's go to coordinate system. We are in Mach 2. That is the sub-spindle work coordinates. We will select our tool. Tool 530 is our drill. I'll say okay. We will go to technology. Drill end. I kind of love this. You can just click on different features of your part and it gives you the exact number. That is awesome. We'll do the full diameter. I'll just do the turning simulation for this because it doesn't need to be crazy. Drill comes in, drills our hole. And is done. Now let's go to turning. So it's kind of a weird little trick. I'm not gonna actually use a chamfer geometry to create this geometry. I'm gonna use a chain and just tell it to break the edge. I'm not gonna actually bore this. So when I select my geometry, I wanna go with solid. We are gonna select this face and this face. And we're gonna say okay. And that will actually generate a chain. And then now I can say tool, select. We have a boring bar in 510. We'll select that boring bar. Technology, we'll just go to break edges. We will say external corners. Put a 5 thou chamfer on there. So let's go to general, Go to finish only. Yep, I can see the chamfer. Okay, and last but not least for our operations, we are going to do an MCO. We are just going to simply eject the part. So we'll go to part eject, asks me a question, I just say yes, and there you go. So now we need to synchronize everything. So if I look at my operations, you can see I have a bit of a problem here. When I'm doing all my contours and my milling on the front here, right now the way SolidCAM has it set up is it will do the cutoff and then it will do my operations in the sub, and this isn't really what we want. We want our operations to happen simultaneously, so I need these operations to go up here. So it's not a lot of work. All we have to do is delete our synchronizations. We resynchronize them. I right click on this and I say add new workpiece, and that brings it up here. And then I just click on this sync right here and I say delete it, and there you go. Just like that, everything is synced up. We'll save and exit. All right, so we have all of our toolpaths programmed. We've gone through and we've synchronized everything. So now let's hop into our machine simulation and actually watch what this is gonna look like before we post it. And what's nice here is because we have two machines technically running, I can use the two views to watch everything at right side. That'll be my counter spindle side.
Two, three, can you hear me? Yes. Good. Dear students and dear parents, So we finally meet at the end of your studies, and we can proceed to the final tests. Hope you did your homework. Sorry? Did you do your homework? Who is certified? Associate certified. Hands up. Wow. So we will see. Okay, test is not easy. Look, I have a good news for you because, well, you can choose from many types of different tests. We are coming to your certification. You are supposed to be certified. You can choose. You can have test, you can have certification to be a salesperson, and I was really hoping that you are all after your sales associate certification. So next time, don't tell me you are not. Because this is coming soon. And even later, there will be another one. We also have, as you know, we have technical certification. And again, I think you were supposed to be technically associate certified already, because we are very soon launching technical professionals. And we will continue, of course, higher. And we already launched academic certification. Academic certification is important part. Yes. Agree? Michal, as Global Educational Manager, is running this certification, and it's important to certify teachers and later also students. So again, wow, where are my slides? Here. And when we will be best, we will have schools which becomes providers of SolidCAM academic certification and training. So we have certification. Let me tell the story. When we started with our partners, with Kennametal it was, I think, then we were considering how to train them, because they wanted to train people all over the world, hundreds. How to do it. So Sydney made videos for training. We sent them around, but we never knew if they really watched this video, how good they are. We wanted feedback. That's why we have this. Then we were thinking about you again, our internal staff and the reseller staff. And we were thinking like this. There is a lot of technical education from our side. We have documentation, we have webinars, we have everything, and technical people, they are really good in digging inside our software. They enjoy it, and they want to know every function. Salespeople, we need to understand it. Not necessarily use it, but we need to understand it in a clear terms, why we have this function, why we are asking money for this function, why I have to convince this customer to buy this function. This is for sales. So we directed our effort also on the sales side, which is a little bit different, of course. Now, we really want to know from you that you are certified, which means you have basic information. And I will give you an example how this certification is done. Wow, okay, nice. Hey. Tell me where I should direct this so that it works. Okay, now it's working. So we have certain purpose with certification. We need to validate your expertise and skills. We want to boost your knowledge. And for you, it could be good for your career, of course. So we are trying to give you yourselves the information in a clear, understandable terms, because, well, you all may be very experienced, but we have new people, right? New salesmen are coming to our companies. New people are coming to our partners, or partners are coming to us and they don't know about SolidCAM, they want to learn as soon as possible what is SolidCAM, how it works. So this is how we are explaining. It's very basic, right? We are explaining what is 2D shape, so what is 3D shape. We're explaining what is 5-axis part. We are starting from the basic for beginners. Don't be like, as I say, I know you are experienced, they are not, okay? So we need to teach them. These parts we are cutting. Then we are showing the structure of SolidCAM, again, to explain them how SolidCAM is constructed, what we have inside. They need to know everything, what we have inside. They are selling all of this. And also explain what is a 2D part, how it's defined, and why we are selling 2D milling just for these 2D parts. So it's a part which is defined by dimensions and tolerances and high precision and so on and so on. We are explaining, this is 2D part. Nice. We are explaining what is 3D part. Is it too basic? Not for newcomers. Definitely not for newcomers. Wait till we have professional certification. It's going to be a little bit more difficult, I promise. Okay, so I believe we are offering in our certification program both education and certification. And there are a lot of managers among you. You need to ask your people to be certified, because then you will have a feedback that they know what they are talking about. Even these basic things. You need new salesmen, you need to educate them. The best way is to go to our certification portal. This is, I always struggle to explain indexing. Now, indexing explained, right? Very easy. Of course, we have one big lecture about eye machining, because this is very important, so we are trying really to explain so that these salesmen understand. And they can explain to customer what is eye machining. This is one slide. As I said, we have a full lecture. And also, we are showing them what machines they can use, and so on. So, Swiss-type machines to explain. I think it was 2 years back when I was explaining mill turn on a lecture, and somebody come to me and say, oh, this was good, it was very basic, that's exactly what I need. Was it you? I think so. And of course, if there is a new salesman, he doesn't know what is post-processor. So we have to tell them, so this is what we have. Right now we have active sales associate basic level of certification, which deals with the basic knowledge about our product, about SolidCAM. We have technical associate, which is very easy. I think whoever tried, it's like, yeah, but it's really basic. Now we have academic certification, because we have an educational policy based on these certifications, and we are going further. We have a team. We have Michal, who is coming on the next lecture. We have 2 great women in India. We have Mila Zlotnikov, who is designing our portal and helping us with a lot of graphic issues we have, not only graphic issues. We have, in US, we have Scott Nail. But originally, I was building on something what was created by Kevin Rankel. I was cooperating with Ken Merritt and John D'Amico. These people help us from the beginning. Now we have a team, we are working, we continue further, and this is what we will have very, very soon. We have SolidCAM 2024. You will be certified for What's New 2024. We have it almost ready. We have almost ready technical professionals, so those of you who were disappointed that it was too easy, they will have better one now. The same with sales professional version. We will create a special branch which you can use for certifying your partners. It's not necessary that you use it, but if you might, you know. They are having our licenses, they are working with us. You are training them, so why not to have some feedback about how well they know our product? There are many other. We will have certification for Solid Shop. We will have certification for iMachining, which I already talked with ScanMerit, that we will start working on it. The important thing is, for you, is the knowledge. For managers, it's a feedback, right? And definitely, these certifications define certain minimum, which you need to know, which you as a staff, whatever staff. Salesmen, even SolidWorks salesmen should know some basics about SolidCAM in your company, right? So sales associate is perfect just for that. So certification is a project which is a long-term project. We are building up and to the wide. So I hope that next time I will invite now Michal. Emil is coming. Michal?
Okay, so Ivan created this great certification. Congratulations.
Thank you.
But if you don't use it, really, so I want you to add to the portal a place that shows every reseller, branch, and affiliate how many of his people have done this there. Okay?
Okay.
Then I could follow it up myself. Okay.
Let's do it.
Hello, everybody. Hello, SolidCAMers. My name is Michal Ševčík, and I'm from Czech Republic, and I'm responsible for global educational activities. And let's say we have quite extraordinary scenario in comparison with other presentations because it is a teamwork. And always, if you are in cooperation with schools, it is only about the fostering and the support, which is crucial for us. And I'm really happy that guys from the West Bohemian University is a really long-term educational partner who's been leveraging and utilizing all kinds of licenses, certification, post-processors, and all services. And it is, of course, covered by our very good reseller from the Czech Republic, which is called Solid Vision. Hello, guys. And where is the...
There.
Okay. Yep. So, you know, I would say that there were lots of very inspiring presentations. But what I really remember and what I want to highlight are two presentations. The first one, Dr. Somek's presentation, and the second one, Michal Ledicky's presentation. And I guess that if you paid, of course, attention, you could see the common thread of those presentations. And the common thread was expressed by very strong push on education as a crucial and a strategic sector for further companies' development.
You mean a threat like, not you are threatening us?
No.
Okay. Fine.
Just common thread, we call it like a red light, which is, let's say, jointing all the topics. And the education, you know, the really first business, Dr. Somek, really first business was for education. So, and as far as I know, Gerhard Lager from Germany, Stefan Speiser and Michal Ledicky, I guess that they're building up the huge German success really partially on education.
So you mean that Emil was really first educational manager?
Exactly.
Ah.
Exactly. And that's the message. So, SolidCAM for education. We have many tools how we are able to be very active in a global role of supporting the schools. Term licenses, academic certifications, which was described very detailed way by Ivan, and of course, marketing and technical support and the research licenses, which are quite new. We release regular research policy since this November, this year. So please focus on your regular business on research institutions and the opportunities you have in your countries. No, back. You know, the story about the term licenses, what I want to, let's say, a little bit remind is that the SolidCAM license for schools has 50 seats, and it's fully equipped by all modules, including 2 and 3D eye machining, which is also important for education. Ivan?
I think that you need to explain why term license. It's because we had many schools before which are not paying subscription. Actually, we don't even know if they are really using SolidCAM. So why we have them? So term license is great because first, the cost is not so high, and second, it stopped functioning. So if they don't care, we don't care. But if they work with us, okay, let's go.
Exactly. So please, who is already certified in academic branch? Perfect. Please, great. Please, really do not hesitate and do not wait. Do that. Be certified. It's really important to inspire your teachers because we already released, I guess it was at the end of June this year, the basic certification, which we call Academic Associate Certification. It is available this year only for teachers, but it's going to be, as Ivan said, available for students as well from the January 25. So please do the certifications and inspire your students. And thank you guys that you are already certified and you are the heroes. So, and this was mentioned many times, and it was really emphasized. I mean, the marketing and technical support, in a nutshell, we call it services. And I really can't imagine that Solid Vision in Czech Republic or any other reseller can succeed in case of lack of services and local support, especially post-processors and trainings. It is #1 importance. Never underestimate that, because these guys are living proof of the nurturing through the services, through the post-processors, and through the trainings. So, yeah. Be ready for release our regular policy. Just maybe one important information, what is going to be the prerequisite, mandatory prerequisite for customers to obtain this research. The prerequisite, sorry? Yeah. The prerequisite is to have CAD research license. It doesn't matter if it is SolidWorks, Inventor, or SolidEdge CAD research license. And of course, use your regular price list, multiply 0.5, and this is the new pricing for the research licenses. So, this is the certificate, academic certificate. This is how it looks. So, please, do the certification, don't wait. I know that you resellers and our subsidiaries are helping us with many technical issues about that, and I really want to express my gratitude towards you because it is important. We cannot succeed without you. So, this is the brief timeline about the academic certification. So stay tuned, look forward, and be ready, especially on January 25. That's going to be incredible. Huge onboarding of teachers and students. So, part of the presentation, our friends from the West Bohemian University of West Bohemia, sorry for that, please talk more about, the very close friendship between SolidCAM, SolidVision, and TU, and how you've been leveraging and utilizing the licenses, because, as I said, the university has been using all kinds of licenses.
Okay, hello. Why we use the SolidCAM? Because it's perfect cams, but for us is very important the policy of the price, because for the university is very good. And the main reason is the support. Therefore, we sometimes need to change the post-processor and any other, and the support, it's the perfect. And here is two examples when we used the SolidCAM. First is a job for a Czech company where make the parts from Ariane 6. Do you know what is Ariane 6? Yeah, it's the rocket, new type of rocket in European space group. And in Czech Republic, the company produced the booster from the start, and we start to cooperate with the company. Therefore, our students working at the company, and it was the point when we start create the technology from this part. And the other project, it's students formula. It's the students project when we the students create the whole car, and our students programming the part, for example, the axle and any other. It's very complicated part, you can see, and it's very good training for the students in technology and in CAMs.
Perfect. So, and this is maybe the third part of the story, is the consequence of really educational activities at the university. And Jiří Hruška is a competitor of Czech skills. Who is ever about the World Skills Competition? Raise your hand up, please.
European skills, world skills?
Yeah, it is like Olympic Games in skills and crafts. And it is a very important, huge, and incredible competition. And we are very strong partner of that for years, and supporting guys to be qualified on the European level, where all European countries are competing in many skills, and especially in a CNC. Please, Jiří, could you briefly introduce your activities and your path?
Yeah, okay. So every year we organize the competition, our national competition for our young people up to 23 years old. In SolidCAM, our champion can enter the World Skills Europe, and I would like to give chance to all competitors to choose CAM software which one they want.
Yes, and especially SolidCAM.
Yeah, of course.
Because the SolidCAM is the best CAM for schools, exactly. So, guys, thank you for that. And the next...
We should say something more. Here he is a champion of Czech Republic in CNC programming.
Yes, so... Okay, and our next friend is Aleš Koziek from the vocational school Školský centr Kranj from Slovenia.
You are right, exactly.
Please tell us.
So greetings also from my side. If we go to the next slide. This one is not mine, but we will continue.
Go ahead.
Školský centr Kranj, like Michael said. Here we have a topic. Actually, this is just one small part of my presentation. The whole presentation will be available at Michael if somebody wants it. And my thoughts are, why should schools use SolidCAM for teaching CNC technologies? And here we found some basic or main answers. In the new politics of education licenses, schools will get licenses for free. Of course, conditional. Second, they can display real situations of CNC machining. If you use Solid Verify, if you use machine simulation, you can see the real results, the results which will appear on the machine later. So that's why, if you are going back, maybe you don't need such an advanced, such an expensive CNC machine. Next thing, each student can work on his own, her own CNC machining project. If you want that the students will be, I don't know, all the time involved doing some projects, if you have that machine for that, you need more machines. More students you have, more machine you need. In this case, you use SolidCAM, you start learning it, and in the meantime, we can continue on multi-level learning, self-learning. Maybe somebody doesn't understand what that means. Multi-level learning, from my experience, students who come to our school, they don't know nothing about milling and turning. By using SolidCAM, they learn how to mill, how to turn, plus they learn CNC programming. It's very simple. Next, no maintenance cost.
Great.
We know the machines are very expensive. Why not use SolidCAM in this case? The machine simulation is impossible to break it.
Okay, thank you for that. We are really limited, but at the end, I want to show you one from you as a reseller are really very eager and enthusiastic to do education. Haze, please come on the stage and briefly, very briefly, introduce yourself, your activities, and we can wrap up. Please.
Thank you very much. Hello, everybody. I just promised to do this brief. This isn't my strongest suit, but I'll do my best. I just want to tell how we approach the schools and the market in Denmark, because I think compared to everybody else, we do it a little differently. All of this is really good. Doing SolidCAM without any maintenance cost and so on, it's a really good way to do this. We take it one notch up. We try to do it one more step on this ladder. One of the big issues for schools, at least in Denmark, is always pricing. It's always pricing that is the main target or the main focus. So we say, fair enough, educate your students in our system or another system compared or at the same time with SolidCAM. We don't want to swap out. We want to offer more solutions to all of the students. In the end, they normally just go for our system because it is a better system to use or easier system to use. But we don't want to swap out anything. We want the education to be better. And we also do post-processes, local training, theme nights for all the teachers completely free of charge. So every single machine at this school, They get it completely free of charge. We go there locally. We do all of the machine, all of the training. We set everything up. This makes a huge difference, and nobody else does this. Everybody sees the schools as customers. We see them as partners, and we use them accordingly. So we work together.
Perfect.
Yeah.
That's the time.
Yeah. Emil now. So we try to approach in the same way that Dr. Emil he did in the beginning of all of this. He started out, as you already mentioned, Michal, 90 seats, educational seats. So if you don't mind, Emil, would you please join us up here and talk just a little bit about that journey and how you started out with the educational side?
That's actually, I don't need this, I have. That's actually a nice story. See, I was working in the aerospace industry, and when the IBM PC was launched, I decided I want to develop a CAD/CAM system for the PC. But I had to find first a customer. So I started looking who needs right now a CAD system. And I came to the conclusion that in education, they need a CAD system. So I went to this event about education, and they showed teachers working on a screen. I said, this cannot be. How can schools have a computer at that time? Remember, this was, I think, around 1985 or something. So after that lecture, I went to the guy who showed the lecture. I said, really, where are you using this computer? I said, it's a big data center, a huge computer, and we have terminals. I told him, but you need a computer at your school. He said, come, I'll show you. The government has paid us to develop a system for schools. I went there, and he showed me some software. It looked so primitive. I told him, look, I could give you much better software. He said, no, the government has paid us. I saw there was nothing to do with him. I went out and I called, there's in Israel a network of schools called OUT Network. It's a worldwide network for technical education. And I knew the pedagogical manager. I called him, I said, are you in chance looking for a CAD system? He said, yes. So I went to meet him, and we signed a contract. I had nothing at the time. Signed the contract that I will deliver to them a CAD system. But at that time, I was still working in the aerospace industry, so I hired two of my students. I was teaching part-time in university, two of my students part-time, and together we developed a CAD system, 3D CAD system. That's what we wanted to see, the isometry and all the other views. After 6 months, I demonstrated to the old network of schools, and they said, what about dimensioning? I said, okay, wait another 3 months. I had at the time the book of AutoCAD dimensioning, so I gave it to my programmers, and they did it. They did dimensioning. So after 9 months, I demonstrated to them, and they said, okay, now we want it. Now we have to go to our committee that decides how much to pay you for that. Okay? It was a very famous committee that kills you before they give you any money. So I went there, and I had 6 people sitting in that committee, and I said, okay, I have a CAD system for you. They said, why should we pay you? Who are you? So they started really going down on me. Anyway, the negotiations continued, and in the end, they agreed to pay us $500 for each CAD system, and the first order that came from them was 90 systems. That's the story.
Thank you very much, and please do not hesitate to support your schools. It's our commitment. Thank you.
Here. Okay, time for awards.
Thank you.
Yeah, time for awards.
Okay. So now is the exciting time of the awards. So let's start. So,
You want the clicker?
huh?
You need the clicker.
Let me do the clicker. So, the first award goes to SolidCAM GmbH for the exceptional sales result. Wait, of 14.4 million euro in 2023. Again, I wish Natalie could have been here with me. We do this every year, and it's a lot of fun. So Natalie, if you're watching it, we're together in spirit.
Thank you very much.
Emil, come.
Okay, we need more space.
You know, Michael, I asked about 100 people to come on stage for this song. That's the SolidCAM army in Germany.
Emil, come.
Okay, it's okay.
איפה אני אעמוד? פה?
כן.
מתי דוד יעלה?
מה? Hi.
Wow, what a team.
Okay.
Thank you.
I have to say, I love this team.
Yeah. We all do. Yes, we can. מתי אני אתחיל? Put the next clicker. The next award goes to SolidCAM International Support Team. Thank you for your excellent technical and post-processor support.
I see this life like a swinging vine, swing my heart across the line. In my face is flashing signs. Seek it out and ye shall find. Old, but I'm not that old. Young, but I'm not that bold. And I don't think the world is sold. I'm just doing what we're told. I feel something so right, doing the wrong thing. I feel something so wrong, doing the right thing.
This is really the best support team for technical support and post-support we have worldwide. And we have to go into increase this team a lot more.
Okay, and the next award goes to DPS Poland. Highest growth in subscription renewal ratio in 2023.
Shooting for the stars when I couldn't make a killing. Didn't have a dime, but I
Thank you, DPS Poland.
Thank you. Well, the clicker stopped working.
Okay, so in the meantime, SolidCAM Limited Israel, highest Swiss ratio in 2023. SolidCAM Israel team, come on up.
Heavy on your heart, heavy on your mind, wandering the streets tonight. If you're looking for a home, you are not alone. I can be your guiding light. Yeah, you can be the greatest, you can be the best, you can be the King Kong banging on your chest. You can beat the world, you can beat the war, you can talk the dragon hanging on his door. You can throw your hands up, you can be the cross.
Swiss time.
You can break rocks, you can be a master, don't wait for love. Dedicate yourself and you can find yourself. It's all a thing. Let's get high, and the world's gonna kill your name. Yes, I am a dream too, 'cause we are dreamers straight. Always and forever, the world's gonna know your name. Let's get high.
Okay.
Thank you, SolidCAM.
As I said before, Speaker Friedman is the best combination of technical guy and sales guy. So he's selling this like mad.
And the next award goes to SolidWorks Slovenia for the highest SolidCAM sales growth in Europe in 2023. Please come on up. This feels like the Eurovision Song Contest. I'm announcing all these awards. Whoa, that was nice.
You are great.
The next award goes to
Daniel Santos, our rising SolidCAM star.
Yeah, Daniel, come on up here.
Well, Daniel.
He's not here?
He's probably selling Solid Shop somewhere. There he is.
He's here?
You know, in 1 year, he created SolidCAM LATAM with about 19 people already, and he's pushing Solid Shop worldwide. An amazing guy. Come on.
And we know you weren't expecting it.
Thank you. Okay, let's take a picture.
I don't care if you wanna tear me apart.
And the next award also goes to an individual, Zhang Chuan. He is empowering SolidCAM's partnerships in China.
I tell you, the secret of Zhang Chuan, he's smiling all the time. So everybody loves him. All the partners. Right? Zhang?
Cause you're a sky full of stars.
Take a picture.
I'm gonna give you my heart.
He's managing the great relationship with Cindy.
Cause you're a sky full of stars.
Ah.
Cause you light up the path.
So tell the story of this. give him
The story is about 40 years in the business for SolidCAM. We are presenting a mill with 8 horses to smoothen the journey in the future.
Thank you.
Congratulations.
Thank you. And the next award goes to...
One second, let me explain again. Dunker One is managing the relationship with Sim, which is the company owning Tiangong Card, for which SolidCAM today is the integrated CAM solution. So all the China market is now wide open for SolidCAM because Tiangong Card will be the official card of China, and SolidCAM is inside.
The next award goes to SolidCAM Inc. USA. Highest eye machining 2D, 3D ratio in 2023.
Mr. Eye Machining.
What a team, what a team.
All the life she has seen, oh, the meaner side of me. He took away the prophet's dream for a prophet on the street. Now she's stronger than you know. A heart of steel starts to grow. All his life he's been told he'll be nothing when he's old. All the kicks and all the blows, he won't ever let it show. Stronger than you know.
Thank you.
A heart of steel starts to grow. When you've been fighting for it all your life, you've been struggling to make.
So as you have seen, the German team is more than double the US team, but the US team is growing. So be careful, Germany.
And the next award goes to Tekias. The highest number of new SolidCAM seats in 2023.
The great Ilker.
And they stay there. And they say yeah. And they say there. 'Cause all I do is win.
They are like number one several years in a row. Now they have the highest new seats.
You'll be back again. I don't know what's wrong with
All I
this
do
one.
is win, no matter what. Got money on my mind, I can never get enough. And every time I step up in the building, everybody hands go up.
I think the clicker finished its life.
Wait, there's one before that. There's one before that.
One second. Okay.
This one goes to Applicad. They have achieved the highest SolidCAM sales revenue in APAC in 2023. Applicad, come on up.
Maar één slide gedaan? Anyway, the slide is missing, so, but they are here physically.
What a team.
Jirapun, you are the hero. I'm not. Jirapun, he's a SolidCAM hero.
Absolutely.
And
Thank you, Applicad.
Amnalt, wow.
Thank you.
I mean, pass this. I want to go to the fourth, third thing. Pass this.
Lama, don't
No,
you?
I'll do this afterwards. Now, the fifth place. The fifth place in SolidCAM reseller sales worldwide is SolidCAM Z-Set. Come on up.
Thank you very much. It's an honor. Thank you.
Our pleasure.
Thank you very much.
Ah, congratulations.
Thank you. Thank you. Okay, go in the back. In the back.
Yes, we can.
Yes, we can.
We came to win. That's the new thing.
Yeah, mother.
And the fourth place goes to, are you ready? Tactics. SolidCAM reseller sales worldwide in 2023. Fourth place.
Uzbekistan, congratulations. Uno. Stand here, stand for it. Let's go a little more.
Zvika is the manager of SolidCAM Japan. That's why he's here.
Thank you. Regards to the Nakasan.
And the third place goes to SolidCAM UK.
Jack, please change the slides. It's not working.
SolidCAM UK has third place in reseller sales.
Congratulations. Congratulations.
Thank you.
Hi. Ben. Andy.
Enough room?
Okay, guys, good job.
Congratulations.
Second place goes to Bechtle, PLM Deutschland. Come on up.
I've been reading books of old, the legends and the myths, Achilles and his gold.
Congratulations. You deserve it.
Thank you.
Thank you.
Thank you.
Thanks.
Thank you. So, that is a really good place. Second place. Wow.
Wait a second. I have now to explain. This award was for DPS. Now, this year, DPS, Solid Pro, Coffee, and Solid Line combined in one company under Bechtle. So, next year, I'm sure they'll be number one. Techias beware.
Okay, so number one, who do you think it is?
Techias.
Techias! First place.
Okay. Yashar. There you go.
Okay, we have 2 more awards. So, please wait.
Congratulations.
We have an award for SolidCAM India, who has achieved the highest growth in sales. India team, please come up.
Not only the slide.
Falling too fast to prepare for this. Tripping in the world could be dangerous. Everybody circling as vultures. Negative, nepotist. Everybody waiting for the fall of man. Everybody praying for the end of times. Everybody hoping they could be the one. I was born to run, I was born for this. Whip, whip, run me like a racehorse. Pull me like a ripcord. Break me down and build me up. I wanna be the slip.
What a big team.
Congratulations. Actually, there's another prize, the best dancing team.
Hanging on to the visual, I wanna be invisible. Looking at my years like a martyrdom. Everybody needs to be a part of them. Never be enough when the prodigal son. I was born to run, I was born for this.
And the last award, which is to SolidCAM UK, they have achieved the highest 5-axis sales ratio. CAM UK, please come up again.
Five axes, that's you. 5 axes. 5 axes. Then, Mr. 5 axes.
Something that I'm proud of, out of the box, an epoxy to the world and the vision we've lost. I'm an apostrophe. I'm just a symbol to remind you that there's more to see. I'm just a product of the system of catastrophe, and yet a masterpiece, and yet I'm half diseased. And when I am deceased, at least I go down to the grave and die happily, and leave the body of my soul to be a part of me. I do what it takes.
Actually, SolidCAM UK were the first always to push our most complex solutions. Simultaneous 5-axis and Swiss, they are the best.
And now we're going to give certificates to the stars of the month. The first star of the month is Felipe Semenzato for exceptional performance and contributions as SolidCAM Star of the Month. Okay. The next, I don't know if he's here, so I'm going to continue. The next certificate goes to Anders van Friel from Katzis. So we continue.
No, no, he's here.
Oh, he is here. Come.
Here's Felipe.
Ah, Felipe is here. I'm so
He's
sorry.
our salesman star for Swiss in Brazil.
Oh, thank you. This is yours.
Anders.
Anders, this is yours.
Thank you. Actually, Anders is in Katsis, but Katsis now is part of PLM Systems, so he's responsible for all SolidCAM Nordicum. Congratulations.
And the next certificate goes to Jack Maynor, our marketing manager. He was in the back here doing everything. Oh, Jack.
You walked here to get it.
And here's your certificate. The next certificate goes to Anuj Bandari.
Anuj.
Thank you.
You know, Anuj,
Come here.
I tell everybody, you can call me anytime. If I'm sleeping, I won't answer you. He took me seriously. He calls me 5 times a day. Okay.
Thank you.
And I enjoy his contacts.
Thank you. Thank you.
The next certificate goes to Daniel Durica. Thank you, Daniel. The next certificate goes to Shelly Dahan, Matskin. She started out as Shelly Dahan, and then she got married. So now she's Shelly Dahan Matskin.
Matskin.
Yeah. And here you are.
Thank you.
So, but I have to tell you a nice story. Stay here. Linda went to a shop to buy some clothes for children, for her grandchildren, and she wanted to sell her a credit card. And she was so impressed by her, Linda. Next day she told me, we need her in SolidCAM.
I told her, send your CV. She thought I wasn't serious, but then she was hired, right?
That's a good day. That's a good day. Yeah.
And actually, it was a great, great asset for SolidCAM. Congratulations.
Absolutely. The next certificate goes to Anshika Srivastava. I hope I'm pronouncing it right.
Anshika, congratulations. Anshika is our digital marketing manager. I told her I want at least 1,000 people to register for the live broadcast, and she did it. Congratulations.
Congratulations, Anshika. And the next certificate goes to Vladimir Germela.
Okay, Vladimir is not here, but I will give him to him. Vladimir is the best sales manager in SolidCAM Czech. Thank you.
The next certificate goes to another person from Czechia, Yashar Kouncu.
Yashar, you're excellent.
Thank you.
Excellent.
You guys are actually excellent.
Thank you.
That's why.
Okay.
Okay, there are 3 more certificates. And the next one goes to Daniel Santos, our rising star. Daniel, you have to come up here again. I hear you.
Can I say something very quickly?
Yes.
So I'd just like to remind you guys here, this month we turned 30,000 followers on LinkedIn. We started the year with 13,000, and that's thanks to the digital marketing team, Jack and Shika. Okay, this is a great achievement. We double the number of followers in 10 months.
Way to go. And the next certificate, 2 more. To Wesley Rowan Thorst from Kansas. Wow.
Wesley, congratulations.
Thank you. Thank you.
You do an outstanding job.
Thank you.
And the last certificate goes to Simon Summer. SolidCAM GmbH Sales Manager.
Simon, 7 years and 7 more to go.
Yes.
At least.
Only 7? Thank you, everybody.
Get me
And we
some
came
water.
to win. Okay?
Okay. Okay.
Wait,
Time for wrap up.
Wait. I mean, one more thing. By the way, for all those people who won awards, we have the boxes here, so the awards don't get broken. So come and take the boxes.
Wow, I got thirsty talking so much. Okay, time for a short wrap-up, and then we will tell you where will be SolidCAM 2025, and then another surprise. Okay, it will be very short because Michael said the buses are waiting, so we need 10 minutes at least, okay. But the clicker is not working, so this is impossible. Okay, go back, please. Okay, so I'm summarizing just some main points. SolidCAM is the CAM for SolidWorks. Final, agreed. Everybody, yes? Every school working with SolidWorks needs SolidCAM for CAM. Every machine shop who uses SolidWorks for some design needs SolidCAM. This is final. Okay, I repeat again, our great strength is our cooperation with machine tool companies. You see here, Citizen, Star, Tornos, DMG, Mori, Brother, with cutting tool manufacturers, with controller manufacturers. In every country you are working, try to find the resellers of these major companies and cooperate with them. Obviously, our great achievement together with Titans of CSC, the Swiss Academy. It's a game changer, and as Donny said, now there is 106 episodes and he's aiming for 500. So people will really enjoy it. Okay, I remind again everybody, we want to give the CAM solution for the most complex needs of the customers. So we are giving our customers more value and they will appreciate us to pay for it. So it's good for both sides. We are giving them what they need and they benefit from it, so they give us what it deserves. Our newcomer, Solid Shop, Daniel Santos and his team. That was complete our ecosystem for manufacturing. Every one of our existing 20,000 SolidCAM customers need it, and all the future tens of thousands. Again, okay. I remind everybody again, our amazing AI solution. We are the first CAM company. Sandvik said something about Cimatron having something in September, but Mastercam not yet. So anyway, we have our amazing chatbot. And as we said, it has all our documentation, also all our webinars. Please move the next slide. So anytime you have any question about SolidCAM, technical or even sales-oriented, please benefit from the chatbot. And by the way, the chatbot is, you can start it not only from inside SolidCAM, just write solidcamchat.com. That's all. Everybody in the world has access to our chatbot. Next. Okay, I remind again one fact from SimData. Next. The market size every year of CAM software is $2.7 billion in 2023. 2024 estimated $2.8 billion of CAM software. So if we have the best CAM and the best teams and the best support, should we not capture more of this market? Yes. Okay, continue. Because today we have only, according to SimData, only 4% of this huge market, and we want to grow it to 10%. Next. How do we do that? By having much powerful business cooperation with our resellers, also branches and affiliates. We provide you with the best product portfolio, with innovation, with technical support, business support. What we expect from you, and I have repeated again in these 2 days, specialized team. There's no way, if you don't have a specialized team for technical and sales and post-processors and subscription, you cannot do it. We have been in this business for 40 years. We know what works, and you have to believe us. We will assist you in pipeline management. Very important, because in the end, the truth in sales is the pipeline. If the pipeline is true, you will get results. Sooner, later, but if you have a good pipeline, you will get good results. And so, to summarize, SolidCAM major target in 2024-2025. Best, I'm asking to best market and provide our powerful SolidCAM products. I'm saying this to our branches, affiliates, and resellers. And I repeat again and again, give best technical and post-processor support. And in the end, make more and more CNC manufacturing customers maximally productive and profitable. Next. So what's our target? SolidCAM #1 all over the world. Agree? Yes, we can. Next. We come to win. We come to win. This is our message to our competitors. We have the best product, best teams, best support. Be careful. We come to win. Okay, now let's see where is the next event. Jack, show us where will be the next event.